Good morning, SCaLE. Welcome to the security track at SCaLE 22X. This morning we have Georg Link. He'll be speaking on the shining light on the open source supply chain, risk in community health. Thank you very much.
Thank you, Alan. Good morning, Pasadena. How are you doing today? Let's kick off this fantastic new day. And I want to talk with you about our software supply chain and the darker corners, how we can understand them a little bit better using the lens of community health. I'll start with one big idea, or really it's two slides. One is when we are looking at open source strategy, using open source, from what I'm hearing, there is three things that especially companies care about. The first thing they look at is the license. When open source got really started, there was a lot of scares around being sued for using an open source license or revealing IP and having to open source that as a result of using open source. So licenses have been around and understood quite well, depending on who you ask in a company. Security is the other pillar, and we have had Heartbleed and Log4j and several other bigger incidences that have raised the awareness that we need to look at the security vulnerabilities in open source. And the third pillar is the resilience of open source projects and companies. And that third pillar, from the conversations I have, has not been quite as established or has sunk into the mindset of open source strategy inside of companies. And so the lens that I'm taking is to look at the activity in an open source project as a predictor or prerequisite for future thriving of an open source project or success. Or if there is no one maintaining software, then it is for sure going to be abandoned. And that will cause problems. Now, I acknowledge there are open source software out there that don't have a community around there, that don't need a community. So there are nuances to everything that I'm saying, but this is the lens that I have. Why do we care? When we look at open source software as it is today, Sonatype found about 7 million open source components last year, of which they found about 10% being used. So there's a lot of open source overproduction or open source being released that does not make it into products inside of companies. This is noise. So if someone wants to pick an open source library or project or component, then they have to figure out, okay, what is that 10%? Or maybe they get something from outside. So there's a lot of noise. And similarly, of the open source projects, there's only about 15% or so that is being actively maintained. So both on the production and the consumption side, there's a lot of other stuff that we could be using that no one is actively looking at. And there are bad people that have discovered this to be a viable attack vector. So over the last years, there has been a steep increase in malicious packages published as open source inside of the package managers where we get our legit open source. And it's really hard to discover these. Across the industry, the cost of open source or just the supply chain attacks, software supply chain attacks, is estimated to be in the $60 billion this year. That's the current estimate. We'll see where it lands when the year ends. And if anyone says, yeah, well, that's the big companies, whatever, Gartner estimates that by this year, 45% of companies will have faced a software supply chain attack. So it's a flip of the coin whether or not we experience this. And if we take this not just at the industry level, but look at the individual companies level, what the impact is. We know from the SolarWinds example that there was an average 11% annual revenue damage to take care of the supply chain attack. So this is potentially very damaging to know or not know and secure your software supply chain. We already had the introduction, thank you to Alan. My mission is to help open source become more healthy and sustainable, and I do this through metrics. So we'll be talking about metrics today. I want to talk through SBOM, Software Bill of Materials, how we can trust what is in our own software supply chain. I have an example where we looked at dependencies of Kubernetes to exemplify this approach, and then I have some background on the technology that we used. All right, I want to start with a metaphor. Maybe you've heard this, that software ages more like milk than wine. It goes bad pretty quick, and the older it gets, it doesn't taste as good anymore. And when we look at dairy products, and we had a bad batch of milk producing yogurts, you can't go around to every store and try out, is this yogurt affected or not? You'll get sick to your stomach. So we have come up with a method of tracking where the milk was coming from, what farm it came from, where it was, whatever they do with the milk, and then being put into the final product. So that when there is a case discovered, we can go to the shelf, figure out the numbers, and pull everything off that is affected with the source milk. Similarly, we are in the process across the industry of doing the same thing for software right now, where when we build a product or service and we use open source software, which depending on the survey is about 70 to 95% of products, and I think that number is low. I think the remaining 30 to 5% don't know that they're using open source software. Then we really need to take a look at this, because open source software itself has dependencies. And when we don't look at those hidden dependencies or transitive dependencies, then we have unknown risk. This is why we need to take inventory, and this inventory is what we call a software bill of material. It's a list of everything that goes into our software. The software bill of materials, a little bit history here, got more and more attention, especially after President Biden had signed the executive order 14028 that demanded that anyone who wanted to sell into government agencies had to provide that inventory, that software bill of material. And CISA has been very busy over the last 4 years to build out resources on how to build the SBOMs. There are many different types of SBOMs. There's a lot of resources now available. And because it's government mandated, a lot of companies are starting to pick up on this. And the latest push comes from the European Union, where in the Cyber Resilience Act, they're demanding that any manufacturer that sourced components from others, including open source, has to do their due diligence, provide long-term support and updates, work in the upstream. There are a lot of demands that are coming. It doesn't say specifically you need an SBOM, but they say you need to know what is in your software, and you need to manage that. So how do we trust what is in our dependencies? How do we trust this? I'm going to give you another metaphor. Think of your car, if you have a car. And you're driving down the road, and the fuel light comes on. What do? You pull over to the next gas station, you fuel it up, you're good to continue. You have a dashboard that tells you, hey, I need, like the engine light comes on. Okay, you go to the garage, you have a mechanic take a look, they fix it, and after an hour or two, you're ready to go again. This is for a car that is actively being maintained. After about 20 years, the manufacturers stop making replacement parts, and the garages don't want to work on it anymore, and you have an old timer. And I know people who really enjoy driving old cars and fixing them up, and they put a lot of time and investment into that, and they have their special friends that still can fix an old engine. But you start going to the junkyard for replacement parts, and it takes a lot of time and effort. And when we use this and apply it to software, we get a similar situation. When we look at licenses and security, those are things we can run a scanner against the source code. We can look for the licenses. We can look for, are there any known vulnerabilities? There are databases for this. And we can fix it. The resilience part is more where you're looking into the future, thinking, hey, will this still be maintained tomorrow? Or am I starting to see risk here? So this is why I believe there are 3 pillars. And we have different tools available to us for each of those pillars. And I want to focus on the resilience pillar, where we have metrics, community metrics, that in the Chaos project, since 2017, we have been building out standard ways of looking at open source communities and their maintainability and sustainability and the project health. And so this is where I'm going to take this next. And I'm going to put the thesis out there that tracking open source resilience is proactive risk management. And with resilience, I believe this to be the capacity of an open source project to overcome difficulties to continue producing quality software into the future. That there is that core activity of members that will keep the technology updated, that will respond to changes in the market, that will fix vulnerabilities as they become known. And when we look at this as part of our risk management practice, we want to pick those open source projects that have that resilience built in. Because if there's no activity, then the project becomes abandoned, and no one fixes the problems that we find, and it's just not good. I'll just leave it at that. So what do we look at? What are some indicators that we can investigate? This is where the fun really begins. As a first iteration, what we looked at was the demand. Can an open source community manage the demand that they are getting on new issues being opened, new pull requests being opened? Are they closing them at about the same rate? Or do they let things build up and the backlog becomes bigger and bigger? Which tells us there might be a problem with too much demand and not enough resources, volunteers, engineers working on the problems and solving them. The second thing we looked at was how quickly are issues and pull requests being resolved, the lead time from open to close, as an indicator for, well, let's say a vulnerability is found. How long does it take until we find a solution, a fix in the final release? Also, let's say I want to contribute to the project. How long would it take for me to go through the process of filing an issue, making a suggestion, requesting a feature, maybe working on a solution, filing a pull request or patch or a change request, whatever platform we are using. I'm just using pull request because GitHub is very popular as an example. And So we want to have that responsiveness, that things get worked on quickly. And the third bucket is talent. We want to know that the people in an open source project have the knowledge, they stick around, because the longer someone works in an open source project, the more they understand the architecture, the better they understand decisions that were made in the past and how certain changes might affect other parts of the system. So we want to have that retention of talent, but we also understand that in open source there needs to be a renewal, new people coming in. And we want to track how many active contributors are there overall over time. And then the last one, the contributor absence factor, which might also be known as the bus factor or the pony factor, making sure that it's not dependent on just one person doing most of the work, that there's multiple people sharing the workload. So we take these metrics, and this can be extended with other metrics and other things that we can look at, but we need to have, this is why I gave you these three buckets, we need to have a theory of why we want to look at these metrics and what they tell us, because later on you'll see how we can drill in and figure out what we can do to help open source projects. So once we have these metrics, we want to simplify it. We want to, when we look at a software project and it has 100, 200 components or dependencies, sometimes even thousands of dependencies, and across an entire organization, the numbers that I'm hearing are in the hundreds of thousands of open source dependencies that they have. There needs to be a way to filter, okay, where do I need to pay my attention? And so we normalize these metrics and combine them into one score. So each component gets its own score, and we just chose randomly from 0 to 10, and used our experience from analyzing other open source projects to know what are good ranges and where do things start to be risky. So we used our experience from analyzing other projects to build the thresholds when something gets a certain score. What we can then do by having these standardized normalized scores is we can aggregate them. So we can say we have a software component that has a certain number of dependencies, and we can aggregate what is the risk score for that component and all of its dependencies versus another one. Again, the idea is to have some guidance on where do we want to drill down more, because the more we abstract, the more information we lose. And like all models and maps, they're only useful to an extent on giving us a direction, but they cannot give us the same information as if we go and we are in the actual place and look around what's actually on the ground happening. So this is that abstraction that is going on. So I'm going to show you an example. We looked at Kubernetes Golang dependencies, and I want to preface, it's not about judging specifically what's happening in Kubernetes. I just want to give you an idea of how this process, this way of thinking works. Okay, so don't focus on the numbers. Go with me on the process that we are going through. We built the dashboard where we have here a filter. So we can say we want to look at this component, or in this case, the Golang dependencies inside of Kubernetes. And we have, after we apply that filter, we can see how many of the dependencies do we judge to be low risk, medium risk, high risk, or very high risk. Again, the idea is that we can filter down on where we want to pay attention to, because we can't pay attention to hundreds of thousands of dependencies. And then we can see how that risk is distributed across those 7 metrics and the 3 buckets that we looked at earlier. The darker fields here just mean there are more components that fall into that risk level for each metric. On the left, we have low, in the middle, medium, and on the right, high. And then on the columns down are the 7 metrics. So what we can see here, there are several components that are in the high column, specifically on the growth of active contributors. So there seems to be something about just being stale, like stable, that it's not growing, or it's even declining in active contributors. And also with the pony factor, there are a lot of dependencies that have only one main contributor that does more than 50% of the contributions. I think the time frame we looked at was what happened during the last 12 months. So we always look at a period of time because what happened in the previous week is not that interesting. It's always a longer period of time that we look at. So while Kubernetes as a whole gets a lot of attention, when we look at the dependencies, we start to see, okay, there might be some areas that we want to take a closer look at. And we can use this also to drill down and look at individual components. So this is a different view then, where we see the overall score. In this one, it's medium. And we can see the raw metrics. So the more we do this, the better of a frame of reference we have for what the metrics mean and how they rank against others. But the risk value is our judgment, then based on our experience and the model we put in, to see what is low, medium, and high risk. And in this case, we see a lot of things look good, but the lead time is where the high risk is. So if I wanted to support this open source project, I know that I can help with closing issues and pull requests faster. When we look at the Backlog Management Index and the Review Efficiency Index, BMI and REI, which is the ratio of issues being opened and closed and pull requests being opened and closed, that ratio looks okay based on the history and the comparison that we have made. So it's not about there being too much work, but it takes too long to address the things. Or maybe they have old things that are staying open way too long, and someone just going in and helping clean up the old backlog would really help that project. So there are some things that we can do here, and I don't know this particular project. I'm just telling you based on the metrics what are typical conclusions that can be drawn. There needs to be that next level of investigation of someone going in, maybe talking with the community contributors. But it's a starting point. That's the whole reason why we are doing this, as a starting point. In a second iteration, we had a new question where someone said, so how can I see the projects that are most likely at risk to be relicensed? Relicensing is a problem because when a project becomes no longer to be open source because of license change, then we might not be able to upgrade, or we might be forced to pay support, or there's risk, business risk. And so the question was, how do we quantify that? And we added a single vendor risk metric, looking at the copyright inside of the code base. How much is that distributed? If it's all held by one entity, or mostly held by one entity because they had most of the engineers behind building the technology and they're the ones commercializing it, there's a very high risk that when they get venture capital and the investors say you need to take it back, even though you've already open sourced it and commercialized it differently, there's where a lot of the risk lies, based on the examples that we have seen over the years. So we quantified that, and then we also had one for vulnerability risk, looking at databases and known vulnerabilities. Oh, and also you see on the right, the different colors, green, yellow, red, ultra red. We've made that more like a stoplight, was another request we had. The next iteration that we are working on right now is bringing it closer to the developers. So the dashboard is good for a controller or a manager that wants to see what is happening across everything that we have in our software bill of material, in our dependencies. But if we can catch it earlier, that would be good. And so we're working on an implementation to get it into the CI/CD pipeline, where developers within minutes will get the feedback. So the CI/CD pipeline builds the software bill of material, which is something I hear a lot of companies are moving towards. And then we take that SBOM and enrich it with the risk scores for each component and return that to the developer, or specifically any alerts or warnings, or if it's over a certain threshold. There, of course, then needs to be some analysis where maybe a component doesn't get a good risk score, but it's the only thing out there. There also can be cases where quite the opposite of activity is what's wanted. I know a medical machine manufacturer that says we are using open source that was validated by research, and we have gone through the whole certification process. And if there is any change in the open source algorithms, whatever we are using, then we have to go through the entire certification process again. We can't sell the machines anymore. And so they're stuck on that version, and any changes are a risk. So there's nuances to all of this, which I acknowledge. All right. So this is the approach. We have looked at a lot of things together already. We've looked at why we care about our software supply chain, how the activity today can be an indicator for the success or abandonment of a project in the future, how we can look at some basic metrics to get an understanding, a basic understanding, and focus our attention. And so I want to talk about the technology, the open source technology that is behind what we built. The Grimoire Lab software has its roots in research. Back in 2004, the LibreSoft team at the University Juan Carlos in Spain wanted to understand how is it possible that volunteers on the internet are building high-quality software. That was fascinating, and there's a lot of research in that time looking at open source. And so they open sourced their tools and started a company around this because there was enough commercial interest to get insights and analysis into open source projects and asking competitive questions like, if I adopt this open source technology, will I be able to contribute to it? Or what's the future prospect of this? In 2016, it was completely retooled to be built on Elasticsearch so that the database, the structure of the data is very flexible, and there is a dashboarding solution already built in. Before, every time there was a new visualization, it needed to be hand-coded, and the SQL schema needed to be changed. So switching to NoSQL was the goal here. And I'm going to say already, we're going back to SQL because NoSQL is really hard for developers to think and get the data out. More people are trained on SQL, and so we're adding a SQL interface again. In 2017, we started the Chaos community to bring people in open source, companies, foundations, maintainers all together and build a standard around how we look at community health and metrics and the tooling. And last year, we released the first 1.0 version of this tool. So it's been in the making for a long time, and you see a lot of logos at the bottom from companies that have used the tool over the years. You may have seen the Mozilla Rebel Alliance report. It's a very beautiful report. I highly recommend taking a look at that. The data that is in the report about how Firefox is built, the Thunderbird community. One of the key things that I really loved that they did was look at the impact that their in-person events have had on the open source community, and really showing that people who come to events are more integrated afterwards and contribute to more parts of the project than otherwise. So there's a lot of cool things that we can do with this tool. It's also the foundation of other platforms that have been built on top of it. Biturge Analytics, the Document Foundation has it. Mystic is a research project at the Rochester Institute of Technology. The Linux Foundation Insights platform built on it. And OSS Compass out of China. I think Gitti is behind that. The general process that this tool goes through is to take the data, collect it, and there it has more than 30 different platforms that open source projects are on, from, of course, GitHub, just Git repositories, Gerrit, GitLab, Jira, Confluence, mailing lists, Slack, IRC. The idea is that anywhere where the community is, we want to get that data, and then in the enrichment phase, normalize it, standardize it, where we can combine the data, and then visualize it and report it so that we can draw insights from it. The architecture looks like this, where we have a lot of cool names like Percival and Sorting Hat and Mordred and King Arthur. They all do their part. So the Percival, the loyal knight, is sent out to retrieve the data. That is the component that connects to the APIs and gets the archives and gets the raw data. That is put in JSON documents into a database from which we then do the calculations and the enrichment. Because, for example, we might get when an issue was opened and closed, but we are interested in how long was that time in between. And so those are calculations that we do. Sorting Hat is a really cool module that we have, because who has ever used more than one email address? Right? I don't know how many. Or different usernames. And being able to say, hey, this is actually the same person in my community, and to say, okay, I also know what organization they work at. Now I can track the activity, the journey of someone through my community, but I can also see, because I can affiliate them with organizations, what organizations are active in my community. And I can see things like, okay, I see this very important company is starting to have fewer people engaged. And there's a lot of things that we can draw conclusions from with this information. I also want to do a quick excursion into being mindful about data privacy. The GDPR, the General Data Protection Regulation from the European, is like the gold standard. Other states here in the United States and other governments have adopted similar frameworks for protecting personally identifiable information and putting more rights to the people about their own data, like names and email addresses and login. And so the question we have to ask ourselves is, do we have to do opt-in to process this data, or can we do opt-out? And with open source, any contributor that contributes to open source knows that their name and email address will be associated with their contribution. That's part of the transparency that we demand and have established in open source. It still does not yet qualify us to analyze that data. We need to do another analysis and weigh the benefits and the risks to the person. And oftentimes open source communities say it is more beneficial for us as a whole, as a community, to do an analysis of how the community is doing than the potential risk to the individual by processing that data. And so oftentimes in open source, we are allowed, even with GDPR, to do that data analysis, but we may want to have to talk to a lawyer to confirm that, yes, the rationalization is okay here. And of course, we need to offer anyone that says, hey, I see myself in this data, please remove me, that we have mechanisms, and we do in Grimoire Lab, to remove someone and anonymize them again. A quick look ahead, what are we working on right now in this technology? Grimoire Lab is on its way to 2.0. One of the things we are improving is the maintenance effort. Right now, to configure, there's a lot of configuration files that someone has to edit manually, and then it's a JSON document, and if you don't validate the JSON, then you break your installation. Building a user interface on top of that will make it easier. The other thing we are doing is scalability and performance. We built this initially to analyze communities from like the perspective of a community manager. And so if you have 50 or 100 or even 1,000 repositories, you're looking at a big community already. Now we are looking at an SBOM of tens of thousands of repositories, and it has to scale a lot more than what we used to have to do. So the scalability is something that we are working on right now. And then also integration with other tools, like what I was showing with the CI/CD integration, getting an API and other measures in place so that we can more easily integrate the data and make it available elsewhere, and the SQL interface that I was mentioning earlier. How to get started? The open source tool, you can go to the tutorial. You can find ways to get started there. There's a Docker Compose, and that's one way. We also offer commercial support if you're interested in talking with me about that. And so I want to close the talk by revisiting real quick what we've covered. We talked about how it is important for us to look at the whole software supply chain that we have. And there are parts that we just don't have the time to really pay attention to. So we need a way to know where do we need to pay attention to. And we've looked at security and licenses as important factors, but resilience as the third pillar. And looking at the health of open source communities, the activity in the projects as a guiding metric where to pay that attention, and how we can combine that into one score so we can compare across all of the projects, because every open source community is different. So we need to have some way to guide our attention. And I want to thank you for being here this morning. I hope you have a wonderful SCaLE, and I'm happy to have a conversation for the next 20 minutes. So thank you.
Very interesting talk. Thanks so much. The sorting hat component seems like it would be able to produce data indicating reputational score of contributors. I didn't see that specific data, but it seems like it could, like potentially a aggregate reputational score for the project of the contributors, so that if somebody's contributing in positive ways to many different projects, that would increase their reputational score. And so basically trying to identify somebody who's trying to undertake a supply chain attack. So just wondering if that's something you're looking at doing.
It's an interesting question. We have, in our own analysis, stayed away from analyzing the specific contributors. I know there are people who look at the journey of contributors into projects, and it might be possible to do. It's something, especially since the XZ-utils scare that we had last year, where a lot of attention is, okay, can we understand what the individual contributor is, where's their background, where are they from, can we trust them? And I'm not involved in that work, but the data is the same, right? We have the activity level data, what everyone did. And so coming up with the algorithms or the ranking or the scoring or whatever analysis we want to do on it.
Yeah, so the left pad attack in 2016 was one guy, published a single library that was used by like thousands, tens of thousands of projects, and that he probably would have surfaced when he took over the project. So there would have been a change, right, in the contributor, and it would have been one contributor, and the median reputational of that one contributor probably would not have been high.
There's a second component to all of this analysis that we did not talk about today, and that is looking at the importance or the severity of or there's another word for it, for an open source component, how often is that represented in our software stack? How critical is it? How close is it to the outside? So what are the attack vectors or the use cases where reachability, all of those questions come in, where you may want to weight the risk score in different ways based on the exposure risk or whatever, exploitability, all of those things. So we didn't talk about any of that part of the risk analysis and risk management, but that's also part of it. Back there.
Thank you very much. Two quick questions. This is, first of all, how do you pronounce? No, Grimoire. Grimoire Lab. The Grimoire. Is the Grimoire Lab deployable within a closed cluster? It's open source, but I get the feeling the data behind it is what is really making it work. And the second question is, I noticed you were using Elasticsearch. Have you gone to OpenSearch? Is it just in our institution, people refer to something as Elasticsearch, but it's just the index search engine, and we've mostly deployed OpenSearch, so changing habits is a lot harder than changing components sometimes.
Yeah, thank you. To the second question, we have fully migrated to OpenSearch. I just forgot to mention it. Yes, we built on Elasticsearch. They changed their license. We wanted to stay fully open source with our solution, and so we switched to OpenSearch. Now that Elasticsearch is open source again, well, sorry, they missed the out on us. So, this first question. When you deploy Grimoire Lab, it comes without data. And you configure it with, these are the community platforms that I want to look at. These are the repositories, mailing lists, archives, and so on and so forth. And then it needs access to that data. So it needs to be able to call outside, call the GitHub API, call the mailing list archive, wherever the data is, to collect it. And then after a day or whatever the cycle is, it will go out and get new data. So it's not live active data. It is a little bit behind of what's actually happening in the community. For the purpose of the analysis, because we're looking at what happened during the last year, it doesn't matter what happened in the last 3 days. We're looking at a bigger time window, so it works. But you need that outside access for it. Over here and then.
Thanks, Georg. The slide that you had that you listed the 7 factors for the first time, has anybody done any analysis? Yeah, sorry. Couple more. That one. Medium lead time for pull requests. There's been a couple of projects now. I've seen Ted So talk about it with the Linux kernel, and there was a really well done blog post on Postgres. So key infrastructure projects where pull request times are getting longer because of the delicacy of the change to these critical components. So when you say there's a lot of nuance here, like, is anybody looking at that kind of thing yet?
The way that we are approaching the nuances here is we are looking at similar kinds of projects to figure out what are the thresholds to look at. And then over time, so we also had an experiment where we gave this tool to different departments, and different departments wanted their own risk thresholds, where they know more about the components that they're using, and they said, no, we need to adjust what we consider risky and not risky. So there's an element of customizability that we need to provide to make it useful to the different teams. It's not one approach that fits everyone. It's a tool to help us focus on where we, and sift through all of the components. Because I've had conversations with engineers that said, by chance, I looked at this component. There was something that caught my eye, and then I realized, no, we need to change away from it because there was a contributor that was in Russia and whatever the reasoning was. And we need a more systematic approach, so it's not just by chance that we find these.
So it sounds like if there's multiple instances, yeah, is this good? Okay, we got. So it sounds like there's more than one instance that would be running out there, and more people will run instances, and so the crawling of GitHub and mailing lists and other, would kind of be like maybe redundant work. So I wonder if there is maybe a common interest in kind of a common data sync that maybe could be hashed, and then those hashed could be anchored on the various blockchains so that we know that proof of existence, this collection of data at this time. Maybe there's a need for that. And then the other is a 3-day delay. My generation, millennial-ish generation, Gen Z, if it's online, it should be in our database. It should show up in the analytics. So how would there be any? What would be the anything in the way of getting to data that has a latency of like not more than a couple minutes? Would be my other question. So.
Yeah, thank you. One of the issues is indeed that we right now have to run the analysis and collect the data for every different instance. There is no effort right now that I know of to create a central database that makes this data available to everyone. GitHub Archive is pretty close, at least for GitHub, to have one place for this. So the answer is, also I know other people are asking the same question. Hey, can't we just have one public metadata set about open source projects that we can all get to, and raises the floor for everyone, and everyone gets access to this, makes it easier and cheaper for everyone to do this kind of analysis. So those conversations are happening, but I've not seen anyone take that step. Did you have a question, or did you want to respond? Okay, I have another one there, and then back to you. And then the other question you had was about the real-timeness of the data. It would require a different data ingestion than what we have right now. It's very possible. One of the key challenges we run into is API keys being exhausted, and so we can't collect fast enough because of the slowdown that is being imposed. But you want a quick follow-up?
So if we have a common data sync, and it's kind of common to multiple players, then perhaps we can have multiple API keys that are throttled so that we can all kind of, yeah.
Yes, API key rotation and so on is something we're using.
Hi. I just have a question about the analysis of a dependency. Is it all about a static analysis on where are the package and when they are used, or do you have a runtime to, for example, check what are the packages that are actually be used in your application and what are the dead codes there? So do you have this kind of runtime, or it's all static analysis? And then I have just another question. Maybe I just ask this other one. It's about GDPR. Is it possible to do opt-in? Because I don't really understand how would be possible, as you have the main package, but then all the dependencies. So even one community is okay to gather the data, then you don't know that the others one are okay also. So I mean, it's quite complicated there to have GDPR compatible.
So to the GDPR question, doing opt-in, there are so many challenges with doing opt-in for the data analysis that no one has attempted it, at least no one that I know of, because there are many people that come to an open source project, they contribute once, and then they leave, and how are you going to find them, track them down, and ask them? They might change the email address might not even be there. They may have shown up in a forum, and you only have the username, and it's not even identifiable, which at that point it doesn't matter, because it's not PII. But still, you won't be able to get consent from everyone. And so opt-in, I've not seen an example where that has been done. What we have done in the Chaos project is we have a data policy for the entire project where when you join, it's on our website that says we also have a dashboard. So be aware, when you're here, your data also shows up in this dashboard because it's a community service, everyone can see this, et cetera, et cetera. To your other question about analyzing where components are being used and more of the severity question or exposure question, the approach that I was talking about today assumes you've already done that work and you give us an SBOM, and then we enrich the SBOM with the project health information. So that is a prerequisite step where you need to identify where am I using stuff. And I know companies that are storing their SBOMs, they can query them, they can see how often a package is showing up and where it's showing up and all of that information. But that's a different solution. I was talking about how do we get more information on what we're using.
This is kind of in reference to your question earlier. I believe Salsa is a project that is providing a defined SBOM format that could possibly be used for people to at least publish SBOMs in a way that would not require folks to individually need to go and generate them. So that could be one potential thing for you to interoperate with.
Did I understand it right that you're referencing a Salsa project that is helping with generating SBOMs?
Providing a format in which SBOMs can be created and we're defining what an SBOM looks like.
Okay, so Salsa being a format for SBOMs. The two main formats that I see in the wild being used is SPDX, which is the Linux Foundation project, and then CycloneDX. And those two are the two that I personally see most of the time. I have not seen Salsa as an example.
There's lots of different organizations that are chasing this. CISA is an organization that's very involved with it, and they've got the SBOM-arama, and they've got a lot of working groups. OWASP does as well. But yeah, insofar as accepted formats, CycloneDX and SPDX are definitely top two.
Yep.
Looking at the slide, you might want to add sort of a section on financial stability, and perhaps as a high-level abstraction, you could talk to the project's term structure, kind of an aggregation of what kind of portfolio of financial contributors, if there are any, whether it's an independent developer, self-supported, kind of abstract that into what kind of a term structure the project has, longer being more stable, and but kind of a way to see into the finance angle of many of these projects, because that's an important need on their part.
So the question I have in return is how automatable is the data collection for that piece of information? Because these metrics are chosen because we can automatically collect them over a wide set of dependencies and libraries. Yes, those other questions around financial sustainability, who is backing the project, and so on and so forth. There's a lot of things that we can look at that are really important, but we can't automate it quite yet. And there's a funding YAML that projects can provide in GitHub, where they can point to places where people can contribute. If they're on Open Collective, we can probably get data from there, but even that is not as widely available. And then we have a lot of foundations that don't reveal the financial status, but we might be able to find on the website who are the main companies that are paying for being on the board and so on. So the question is, how do we scale that analysis? Or do we leave that to the next step in the analysis where we can use metrics that we can automate to help shine the light into the dark corners of the software supply chain and say, I want to take a closer look. And then when we do that analysis, we can also look at those other things like financial stability.
Just quickly, if a foundation is a 501c3 in the United States, you should be able to somewhat automate the process of requesting the 990s every year from the IRS and just sucking all the data from there.
That would be great if they filed them in a timely manner, and also if they were to provide that in a very detailed way, because a lot of the foundations have many projects, and you may not get the breakdown of how the money is distributed. So, yeah, it would be nice if there was a clearinghouse for that kind of data. All right, we will wrap this up. I thank you again very much for being part of this conversation. Thank you for listening to the ideas this morning and engaging with them. Thank you. So the slides that are on the SCaLE website are from before this morning. I made some minor tweaks this morning. I'll upload the current set later.
Am I audible? Hello.
Am I audible at least? Am I audible? Okay. Yeah, I know. Okay. Okay. Sorry? Is that fine? Okay.
Welcome back, everyone, to the security track here at SCaLE 22. Our next speaker is Sharama Sharma. Look at your topic.
Sorry.
Sorry. And he's presenting on managing confidential computing environments with OpenStack. Thank you.
Sure. Thank you. Good afternoon. Welcome to all of you. I know it's kind of an odd time, probably a lunch time for some of them, and or I would be holding back for you folks to go to your lunch, but I'll try to make it as much interesting, and we can have a conversational discussion here. Any questions, please feel free to interrupt me anytime in the middle, and we can go through the questions too. Okay? Thank you. And today what I would be covering is in terms of a brief overview of what confidential computing is and how and different options that do we have in terms of confidential computing, and how one of the ways we can use OpenStack to orchestrate some of the workloads that can be run within a non-confidential computing enclave. So that's what I would be covering with a specific demo as well. Yeah. So to just give a quick information of the speakers, myself and my colleague Divya K. Kunur had kind of provided this bio, this particular speaker topic for today. Divya is a senior technical staff member. We both are part of IBM. She is a senior technical staff member and specifically leads the confidential computing offerings like HyperProtect crypto services, HyperProtect virtual services, and crypto appliances. And I am Sri Ram Sharma. I am the senior technical staff member in IBM working on Z systems, specifically as a product owner for IBM Cloud Infrastructure Center, which is kind of built on top of OpenStack and provides infrastructure as a service on IBM Z systems and Linux One, which is mainframe-based systems. So to quickly get started on what topic do we have today is what is confidential computing. So if we look at the big picture, confidential computing is the protection of data in use while performing computation or using that particular data for your computation in a hardware-based enclave, which is supported with trusted encryption or trusted execution environment, which is running in a trusted execution environment. So while we talk about data in use, which is being used for the computation, it is secured in that particular enclave. So if you look at some of the different scenarios, here the data protection at rest is taken care of using encryption and crypto libraries, where you can encrypt and decrypt data which is at rest. Data during transit is also kind of taken care of using TLS and some of the other transport layer services which provide security for data in transit. But primarily what confidential computing looks at is how do we ensure the data which is being used and processed during by the application during the computation or any other consumption is kind of kept secure. Again, a little bit detail in terms of how it is about protecting data in use. If you look at data in transit, we do have the data that is starting from endpoints to the computational VMs or vice versa. So this data that is being transmitted through the network is kind of secured through end-to-end encryption. Primarily TLS is one of the options that is used. And on the right-hand side, if you look at the data at rest, which means I do have the data which is already stored and is on the storage, but somebody could access the storage and use it, and that's where we make use of data encryption on the device itself. It could be at the data set level, or it could be at the storage volume level, or it could be at the physical device level. But the main paradigm of confidential computing comes in when we want to secure that data while it is being consumed in the virtual machine or application itself. And there are multiple threats that it could impose, where in terms of memory attacks, people can take a snapshot of your running VM and be able to access the data which is being computed. In the same way, hypervisor-based attacks can also happen. And insider threats, where somebody who has access to that particular compute VM where the data is getting churned out, can also take a snapshot or probably have access to the file system of it and leverage it. So there are multiple such issues that are security threats that could arise, and hence we are looking at confidential computing. In terms of why, again, there are three major aspects in terms of having confidential computing. One is the security of the data, and in some of the industries, say for example banking or credit card usage and so on, or wherever there is an SPI data is being used, personal information data is being used, that becomes a compliance directive from any federal agency or regulatory bodies and so on. So that is another reason. And also in terms of controlling the access to the data, in terms of how do I ensure control of the access to the data. One, we will just go through it in detail now. So if you look at protecting data from the security point of view, there are multiple types of data, right? So in the public data and also the internal, and those data can also be classified as confidential and sensitive. The data which is public is something which you don't need to invest more on securing it, because it's anyway public and people are okay to access it, and that's how it is classified. And some of it is which is internal is still okay with respect to the within the organization or in the within the realm of the organization where we are consuming it. The criticality comes in terms of confidential data and how do you secure sensitive data. And if you look at, there are two ways. One, yes, everybody believes me and I assure you that yes, it is not being looked at, so it is secure. So that's kind of operational assurance. So suppose if I am a on-prem system and the system administrator who is taking care of the VM on which you are loading data and processing it assures you saying, I am not looking into the data, it is just given to you, this is the asset. I do have access to it, but I am not looking into it. So that's kind of an operational assurance. It could be through an SLO or SLA, or could be bound through the legal aspects as well. And when we take it to the hybrid cloud point of view, this is one of the operational assurance that is given. And second way is to provide technical assurance. When I say technical assurance, in addition to the operational assurance that I provide that I am not able to access, I will not access, it technically also constrains the person not to access it. So the technology which is being used kind of limits him out from accessing that particular data. So if you just look at the way how at the bottom of the stack, how we are trying to put it is cloud infrastructure operator can also access the data and application, and customer can also validate and also access the data. However, on the cloud confidential computing side, where the confidential and sensitive data is included, the infra operator cannot access the data at all. So that's the technical way of limiting him from getting access to the data and applications. If you look at the second aspect of why confidential computing, mainly from the compliance point of view, as I mentioned earlier, the increasing regulations and the norms that are coming in from the regulatory bodies and financial institutions, that becomes a clear requirement for protecting the data. So if you look at from the inflection point in terms of how the data sovereignty need to be maintained, earlier it used to be mostly at the data at rest, focused on data at rest, where the regulatory bodies used to provide, saying this data need to be secured and encrypted and also archived for certain duration of time, and even at the archival it needs to be secure and so on. But now, as in when we see there are multiple folks who could work as hackers and try to get access to data, because data is the key resource in the IT area. So, and modernization and digitization has also put up more challenges in terms of how do you secure this data as well. And hence, the regulatory bodies will also include specific requirement that the data in memory should also be encrypted, and also in terms of data during the compute, nobody should be able to catch hold of the registered contents and then be able to decipher from the same as well. So that's another requirement. And if we look at it from the control point of view, it's more from the different personas who would be accessing the data. One is the workload developer or a solution provider. He will have access to the data as well. And at the same time, environmental operator, SRE, who could also have access to the data. There is a separate limit or constraints that we need to set for them. And auditor or security, privacy data, or the government agency itself need to have access to the data as well. So how do we streamline or control each of these personas to have their own specific set of access and not be having more access than what they require for their performing their particular role is also a key aspect. So if you just look at what are the different technologies do we already have in the market, from the AMD point of view, we do have heard about AMD SCV capability, which protects the entire virtual machine itself. So the entire virtual machine where the computation is happening is kind of protected. And this is per VM encryption by making use of specific keys. And the isolation is at the VM level. Similarly, if we go look at Intel SGX, there the production of the specific portion of code is taken care of within the VM. The code is running in a secure enclave, and SGX creates a isolated memory region within the hardware, and that's the hardware support that it provides. So the other option or the technology that I would like to talk about today is in terms of the IBM Secure Execution. This is the protection of virtual machine, as well as protection of the data which is running within the VM as well. So just by protecting the virtual machine, even there we could have specific chances where the operator who has specific access to go within the address space of the VM can also encache specific data that is being computed. With secure execution, it provides a hardware level encryption, an ultravisor, which will be made use of to first secure the VM and also encrypt the workload running within it as well. So here the trusted computing stack or the software, if you just look at it, I would specifically, if you look at from the malicious workload, can also be running alongside KVM guest, and the machine data can be modified. So specifically, the way how it is taken care of is Z15 and onwards. That's the hardware capability built in from that specific release onwards, where the KVM host can be booted up with an encrypted way using secure execution, and that can be done using the encryption keys, which only has whoever only has access to the boot device or the boot file for that VM will be able to bring that up. And also inside that we have a secure guest that gets created where the boot data is also secure using an encryption key. So whenever I'm trying to bring up a particular VM, I will need to key in that particular environment as key in the encryption key as an environment variable for it to boot up and be able to access. And rest of the SSH and other access are also kind of taken off. So how is it implemented is in terms of the protected guest state is achieved using an ultravisor, where we have a different ultravisor table which is having guest specific memory access, which is saved across and not shared with any other guests which are running on the same environment. So how do we kind of secure that particular guest is, as you can see on the left-hand side, the container image provider will have their own OCI-based images that can be built using a secure build process, and that gets deployed on a secure guest environment, and wherever there are workload provider persona has access to it, they need to provide workload specification properties, and that is kind of encrypted by their own keys. And the environment owners, in terms of workload deployer, they should also be able to use their attestation keys to boot up that particular VM or the workload. So that way, each of the workload data as well as the VM itself is both secure and kind of confidentiality of the data is taken care of. So how do we look at it? I mean, say for example, in this scenario, we have a hardware layer where we have the guest state that can be whoever is having hardware operational access can take a snapshot or take the guest state of the KVM which is running the Linux LPAR, and at the same way, the one who has access to KVM hypervisor with those privileges can take a snapshot of a VM that is running and thereby be able to access the guest memory as well. And of course, whoever is able to access the VM services itself, with UID root process, they can directly access the guest memory too. So these are different ways how the data in use can be kind of attacked. But the moment with the secure execution concept that I referred to, here at the hardware level, we do through the ultravisor, the guest state is kind of secured. So any access from the hypervisor state or the system administrator to take a snapshot of the same will be redirected back, or it will be thrown out with an error. And in the same way, the second use case in terms of getting the guest memory access through the KVM or through privileged root process or user IDs are also kind of taken care of. So what it does is protection against malicious operators, the system operators. At the same time, it also protects against malicious hypervisors, and it also protects against bugs in the hypervisor which can be leveraged by somebody else who can use those open bugs for hacking. And if we just move on, where to leverage this particular confidential computing. So we just looked at confidential computing and what is the technologies to achieve confidential computing in terms of where exactly we can use it. So one of the use cases, as you were rightly pointing, in terms of digital assets, could be NIFTs, policy platforms, and also secure AI, where the models need to be, and the data which is fed to the models need to be secure. So that way there is no manipulation of the data at the time of consumption by the model itself, or at the time of inference through the model. And the same way, the security and privacy for data in use workloads, wherever the special privileged data needs to be taken care of. So these are some of the use cases where we can leverage confidential computing. So with this, the next step is in terms of how do I easily orchestrate VMs of capability that I talked about, which can be secure and encrypted, and at the same time, how can I deploy workloads on top of those VMs after I create it on the underlying infrastructure. That becomes a next level of kind of problem for operators in terms of how do we manage this. So for that manageability, what we can do is OpenStack. We have done some changes to the OpenStack, the libvirt provider within the OpenStack to understand and recognize the secure execution capability which is there in the hardware and leverage the same in the OpenStack UI. So if you look at on the, there is a software bundle called HPVS, Hyperprotect Virtual Services, which gets deployed on an image or an LPAR. Here at the, okay, this is seen. Here, this is the hardware layer where we can have the feature code of the firmware that can be used to create specific LPARs or hypervisors or hosts. And on top of that, we have Cube libvirt driver, which has been enabled for secure execution, which is provided by the underlying hardware. And using that, we can create non-SE based environments as well as SE based environments. So it's not required that everything that is running on top of this needs to be enabled through secure execution itself. And all of these are encrypted through keys, and we can achieve confidential computing VMs and deployment of the same as a software bundle using the OpenStack. And this does support for Ubuntu, SLES, and RHEL enterprise Linux images, and also the admin users can enable or disable SE encryption based on and at the time of creating the VM or orchestrating the deployment of the workload. So the point I would like to highlight here is this is not comprehensive list of changes that we have done, but there are certain changes that have been included in libvirt to understand the hardware capability and also be able to recognize leverage those capabilities as well. So one of the use flow is as an ICIC. ICIC stands for IBM Cloud Infrastructure Center, which is an open source, OpenStack based IaaS solution that IBM has. It can even be OpenStack with the changes that we have and that we are planning to contribute back to the community as well. So the OpenStack can leverage the SE capability with this particular user. Say for example, as a customer, I would just need to input the KVM host keys and the base image that I have captured, which is used from a secure build process. And this has to be done on a secure execution enabled Linux image. I build the same, and that gets deployed through the CIC for creating the specific image and then deploying it onto the virtual machine or LPAR, which is created through the OpenStack driver. So, which means in the UI, I will be taking you guys through the specific demo here as well. So in the UI, I will have an option to select KVM as an hypervisor, and once the save KVM is selected, there is a check button using which I can ensure if it is a secure, if this VM that is going to get created or host, that is KVM host that is getting added, requires secure execution capabilities or not. So once I have secure execution enabled, the host that is created will showcase that it has secure execution capability enabled, and any VMs that can be created on this can have a deployment of the VMs which are built through the secure build process. So the next is, how do we take care of the secure image? So the OpenStack also has support for glance, where I can store the QCOW2 based images which are built using secure build process. So while creation of the image itself, I can specify the different, the hypervisor type, as well as the flavor of Linux that I'm using, the distro of the Linux, and if I need to turn this on or not. So using this way, I can create a secure image which can then be deployed on VMs which are created, or hosts that are created with secure execution enabled. And the third part is, of course, the provisioning part. As I said, the image gets provisioned on top of the VM, which is also enabled with secure execution. So that way, so the workload where your service is running is also built using secure build process with an encryption key, and where it is getting deployed is also a secure KVM host, where both of these leveraging the underlying IBM secure execution, from which is the hardware capability, and the way how the workload is deployed on the virtual machine is completely confidential. So let me quickly start on with the demo. Okay. Or should I mirror it? One second. Let me just mirror. So this is the OpenStack-based implementation of infrastructure as a solution layer that we have. I do log into this particular IaaS software using the credentials that I have, the management credentials. And here, if we just look at it, just shows the details of different virtual machines that are running. And these virtual machines are running on multiple different hosts, different type of hypervisors. It could be KVM, which is Linux KVM libvirt-based hypervisor, or it could even be ZVM, which is proprietary IBM Z hypervisor. And we also have details about different volumes and the storage providers that are configured, using which I am configuring, which are connected to my Cinder environment. This also showcases the resource usage of each of those VMs. And now, if I just go look at the management node, so this is the management node, which is nothing but the OpenStack management node, which is a single node deployment instance that we have done. And in this, we also, if we just go to the host side, we see there are multiple hosts that are available already, and I can create specific set of hosts as well. Here in this add host, as I showed in the screenshot earlier, I have option to select any of the hypervisor. In this case, I'm selecting the KVM hypervisor and will be keying in data in terms of host name or the IP address and the user ID that needs to be used for the host name, and the display name for that particular host, the KVM host, and the password for that particular KVM host also needs to be enabled with a specific name of the interface. And this is the point where I will be enabling or using the checkpoint checkbox. By selecting the checkbox, I will ensure that this KVM host need to be of the type secure execution. And of course, this if I have to enable this option for KVM, this has to be on a specific hardware type which supports it. Say, for example, if SGX is supported by Intel based, only on those systems we can leverage SGX here. Z14 onwards or C15 onwards can leverage secure execution. Z14 onwards, we can leverage secure execution. So now this particular instance of OS01E has been created. And here, if we just look at, there are 3 different instances. One is the IA compute and OS006 and OS01E. The other 2 are secure execution enabled, while the first one is the normal KVM, which is available and running in this particular environment, managed by the OpenStack management node. And if I just click on the host and then look at it, the now let's look into the VM creation, image creation part. So at this point, I will create a new VM using the OpenStack APIs. The image name, I specify the OpenStack image name, and then select the hypervisor type, which is KVM, and the distribution to be rel9, and the image disk type to be SCSI, and the source to be file. And I will select a QCOW2 image, which I will be browsing and using it from my local desktop, which has already been created using secure build process that I explained earlier. And if you recollect here, I have again checkboxed that it is a secure environment, which means the image that I am creating now is an image which was built through the secure build process using the encryption key and the workload data which is deployed, and both of them kind of running in a specific VM. So once I create this image, I can see that it is listed in the OpenStack. 1 second. It's getting created. So once it is there, I will also need to look at the networking configuration. So there I had specified KVM flat network. So if I just look into that particular network details, we see only there are 3 machines. I can go into the subnet that is configured and ensure the IPs are all available and listed. And now going to the security groups, I need to ensure this particular subnet that was created is added to that security group as well. and specific ports are enabled. Here in this case, 8080 is something that I am enabling because it will, the workload that I am that I have built using secure build image is just an hello world program to showcase, which gets deployed on an HTTP server, and any access to that server will showcase the hello world as an output. It could even be any specific data or a PDF or a model, as well as I explained earlier. So now the next step is for me is now I have the infrastructure which is secure execution enabled. I have created a KVM host using OpenStack with secure execution option enabled. So these two are in line. I also have created an image which is built through secure build process. How do I deploy this onto this LPAR and boot it up? For that, I will need a boot device or a boot disk that needs to be created. So using OpenStack Cinder APIs, I will configure, the storage provider is already configured. So in this storage provider, I will now create a disk pool, a disk volume. And in this disk volume is, I already have a DS8K, IBM DS8K storage, which is used, and a base template that I'm using. And now I will create a volume with name demo HPVS ICIC boot. And this is of size 100. And I will mark this as a bootable volume. So this bootable volume can be deployed. So only when I create this bootable volume and install it on a secure execution enabled and the encryption keys match, it gets booted up. So I will select the image that was created earlier, which is HPVS stage, and then use that image onto the boot volume. So it just creates an volume now, and now I can click on deploy to deploy that particular image into that into the secure VM which was created. So when I say deploy, the VM instance gets created. I can select a specific deploy target, which is OS006 that I had created, and the compute template can also be of any size. If you just saw that, I can specify the different sizes, which are t-shirt sizes, which can be configured as well in OpenStack. And once I deploy, I will need to assign now the network that I created, which is the IBM default network, KVM flat DHCP, and again the default security group. And here, this is the case, this is the specific point where I need to enter the configurational script. So this is exactly where I will provide the public keys of the workload. The whoever has developed that particular application will be able to give you this key. Only after you provide this key here and click on deploy, only then the deployment of the VM gets initiated. So this is the key, that image builder, whoever has built, the developer who has built the image, and now this deployment of that particular bootable volume is in progress. So I can keep checking on the status of the deployment using the console output, and once the console, what's happening is the images, secure image is getting booted up on the secure VM which was created. It's progressing further, and I can also check it in the logs on the status of the VM as well as the image, on what timestamp when it was deployed, and whether it is deployed in the same VM or so. And once it is complete, I will see a message that the VM and the workload is completely deployed. So this is the IP address of the VM service that is running on top of the secure KVM instance. Now if I just try to, I cannot access SSH to that particular VM to access the same. So only way how I could do is to do using curl. I can see it is I know it is a HTTP service. So I will try to access it through curl. And if I just feed it into JQ, I will see what the contents of that particular service are. What is it actually servicing? So here in this case, it's just outputting the result as hello world. Similarly, it could be any other particular, you are feeding in the data with an environment variable, and that performs the inference and then provides the inference output, inference of the data through the model and provide the result back to you. So this is a specific thing that I wanted to showcase as part of today's topic, and this is the demo as well, which I wanted to share it with you folks. If there are any questions or so, please do let me know. There are specific references also. I will be uploading it as part of the PDF on the SCaLE conference webpage, which can be downloaded later, and some of the documentation with respect to different references for the whole demo that we have built. And I'm open for any questions now.
It seems to me that while you've got the ultravisor involved in there, anybody that can have access to the ultravisor still has the same level of being able to access the guest state and the guest memory that you would be able to do in a non-secure environment from the hypervisor. So how have you protected the ultravisor from attack?
That is only created and maintained within the hardware using the in the hardware, the ultravisor will not, whoever is hardware administrator will not have access to the ultravisor as well. So it's taken care of in the underlying hardware.
Sure, but in the event of a CVE in the ultravisor, there has to be some way to update the ultravisor, and that mechanism could be subverted to take control of the ultravisor.
Okay, let me just go through. I'm just trying to understand your question there.
So with that, go back a couple of slides because that one's adequate.
Yeah.
So the ultravisor is what implements the PRSM level, right?
Yeah, in PRSM
And so
level,
the
yes.
ultravisor is baked into the hardware. It's probably a firmware of some description that can be
It's
updated
encryption.
by IBM.
Encryption of that particular thing. It's not just with IBM. So whoever has is creating, this can even be an a Linux LPAR, right? So in Z world, we can create a hardware level and first level of hypervisor where you are carving out a Linux LPAR. And while you are carving out, you can use your public key or there is an encryption option available where you can create specific keys to create a Linux LPAR as well. Only those who have created access to this will, that is the customer themselves will have access to the ultravisor and not the IBM.
So the ultravisor is under end user control.
Yes, and through the key that they would have generated on the system using the HSM which is on the system.
I mean, that means that each individual VM has different keys to their encrypted space within the ultravisor, so they're separated even from each other.
So here, this is the physical LPAR. On the Z side, I mean, this also includes, you assume one LPAR to be one single system. Coming from the distributed side, if this is a separate EAL5 certified LPAR where you can just ensure anything that is running on the system outside of this particular LPAR cannot have data access to this LPAR or compute or data or memory resources. It's EAL5 certified differentiation which is seen at the hardware layer. Yeah. And it looks like you're still not convinced.
I feel like if there's anywhere you can update that ultravisor operating system.
That is only through the firmware upgrade.
Right,
Ultravisor
the
is not
firmware
an
side.
operating system. It's a firmware.
Right.
It can only be upgraded. But how you get access to the ultravisor table or the area, if I just go to the previous section, the section. So if you look at the hardware, and this is based on hardware and firmware features and can only be built in using access through the built-in private host key. So the private host key remains with the person who is, or the end user or the customer who is creating that LPAR and can encrypt that using the private key that they have.
Right, but in the case of an update, like you've deployed it, you've been running for a while, there's a new release for the Ultravisor firmware.
Ultravisor only provides capability at the hardware layer for you to encrypt.
Okay.
And that encryption is done using the key that the customer would have using their private key. And they will have, even if the hardware operator who has access to it will not be able to access any data within the Ultravisor 2.
Okay.
Because it is secured through the private key, which is used by the customer.
Okay.
If you still have specific scenario
of models and frameworks, and the ecosystem started to have, solutions that support the usage of generative AI. Meta is doing their thing, and Google is doing their thing, NVIDIA is doing their thing. There's a bit of fragmentation, and things are kind of innovating in silos. I would like to see, I think we should all want to see, the ecosystem kind of come together to work on solutions that preserve openness, interoperability, freedom, agency, vendor neutrality, but of course also better security for all of these things. Ultimately though, right, things are moving very fast and we're all very, very excited about the things that we're creating. I also want to, the generative AI market is expected to reach 110 billion by 2030. And what does that mean, right? What does that mean for us as engineers and developers? 72% of businesses are already using or exploring generative AI applications. And this was, my data's a little bit old, it might be more than that now. So this rapid adoption creates security challenges that I think a lot of organizations are unprepared for. And by the way, according to the OWASP Generative AI Security Podcast, which is new and I highly recommend checking out, businesses are really struggling with implementation, but kind of deploying these applications regardless because of external pressure, right? Competitive pressure, economic pressure. And then again, I keep coming back to this, but innovation is moving rapidly. Everyone from large enterprises to small startups to individuals and developers are incredibly excited to jump in and reap the benefits of all those big numbers I kept showing. For productivity too, right? And then people are both building brand new solutions, but also tasked with integrating into existing solutions. Sprinkle a little AI on it, right? Just by a show of hands, we're not a huge crowd here, but how many people have been given the task of developing an AI application or adding an AI feature to an existing application? And is this new for you? Playing, tinkering about with AI, right? So yeah, again, we're going to talk about some of those hurdles and through a security lens. So think about the tools that we have, we're used to, right? Traditional application security tools were not designed with generative AI in mind. They were not designed for models. They were not designed for inference. We used to focus on other concerns, code vulnerabilities. Now we're concerned with model behaviors and concerns that are specific to that inference and things like prompt injection vulnerabilities. And I'll get more to that in a bit, but static analysis, right? We've relied on that for a long time. What's that going to do for us here? So security practitioners have to learn to expand the threat models to fully understand the attack surface in the new generative AI environment and the application types that we're talking about. I think also the nature of generative AI challenges the traditional security testing approaches that expect certain outcomes. It goes back to that deterministic versus not, it forces us to change our perspective. So think about also the interfaces that we're faced with, right? This is, think of a ChatGPT, chatbot kind of interface. The prompt interface itself creates a new and different attack surface that's different from traditional inputs. And then you have things like, we talk about model weights and parameters, and those get into massive numbers, and those could also be manipulated during deployment. Training data also, influences on training data present security supply chain challenges. And then we have concepts of data leakage that maybe didn't exist in the same way before. Output handling, right? So once you enter something into this interface, you get an answer, possibly an extensive answer. And the way that that output handling is far more complex, introduce, again, new risks beyond the ways that we may traditionally think about output validation. So we have some categories, right? Some basic categories, and we'll kind of drill down into some of these a little bit. But we have a model manipulation, right? It's kind of a new concept. That would include prompt injection, as an example of an adversarial kind of situation. Data extraction, right? You can prompt to extract sensitive data stored in these models and in applications. Inference attacks, that's also it falls under that category. Output exploitation, right? Generating malicious content. If you go to a chat Q&A bot and it asks you, and you want to ask it a question about, oh, I don't know, is arsenic safe to ingest, and it tells you it is, well, that's not a safe situation, right? That's output exploitation. And then resource consumption. Like we know about denial of service attacks and taking down our applications, but the types of resources required to operate a generative AI application can also be exploited, overloaded, and that can be used to also get information out in a way that we do not intend. And then, of course, we go back to our supply chain risks. We've talked about software supply chains for the past, I don't know, a while. I hope we have anyway. But now we have new pieces of that supply chain puzzle, and some of that is where we talk about poisoning models, for example. And if we don't know the provenance of our model, this introduces risk. Click. Okay, sorry. And then, I suspect anyway that we've all read examples of incidents involving generative AI applications. Prompt manipulations maybe that bypassed ChatGPT's safety guardrails and produced output that was not desirable. Code generators being used to, oops, what did I do? Well, I've lost the slides. Oh, there we go, they're back, okay. So again, code generators, generating vulnerable code. Maybe we take it for granted that the code generated by a Copilot or something is safe, but maybe it's not. Image generators, that's another good example, right? We go in to create an image, but there are some guardrails in place to not allow users to create certain types of images, but those can be bypassed, and that's another example of risk. Or a customer service chatbot application that allows customer data or user data to be exfiltrated in some way. There was a paper published at the end of last year that described a scenario where an attacker provided a malicious prompt under the guise of polishing your resume. Now think about the current environment we're in. We have a lot of job seekers out there and a lot of people who've maybe been on the job market for quite a while. And it might be pretty appealing to look at some newfangled tool that could help you polish up your resume to land that next job. Well, what happened here is they provided a prompt that included some kind of gibberish. Maybe it didn't make sense, but it maybe didn't look too risky either. Include that prompt, then upload your resume, and what happens is your personal data gets sent off to the attacker. Now, the researchers reported this vulnerability to Mistral, by the way, and then it was accounted for. Thank you, researchers. But these examples do exist. And there was another actual case by that OWASP, I believe, highlighted where their deepfake detection helped prevent a fraudulent hiring attempt. That's a whole interesting story. That's the one in my screenshot here. But my friends at Intel, for example, are researching ways to build trust in the entire machine learning pipeline and have outlined an interesting kind of proof of concept that they feel is key to ensuring the necessary integrity and transparency of the development process, both for safety reasons and security reasons. So modern AI development involves a complex chain of participants. Data scientists collect and prepare training data, right? Machine learning vendors develop algorithms, engineers build training infrastructure. External contractors, in some cases, handle specialized tuning of these models. And then operations team deploy them for use. Each handoff between those different groups of people involved in this application creates a potential security vulnerability. Kind of like a relay race, right? You hand off a baton. Every time you hand off that baton, you create, a little bit of risk. And with AI, these vulnerabilities can, of course, have serious consequences, especially in a world where we might take, the output for granted. So we're working on an approach, and they published an article recently that covers that entire life cycle. So Intel Labs has been researching the problem, and I'm going to share their approach to building this trust. The research identifies two main threats, right? Data poisoning and supply chain risks. The first is data poisoning. Bad actors intentionally corrupt training data. The modifications are typically subtle. They don't necessarily break the AI completely, but they would create specific vulnerabilities that could be exploited later. The second major threat would involve supply chain risks, right? You don't know where your model has come from, potentially. When you download a pre-trained model or outsource the training of that model, how do you know if it was trained correctly? The model might contain hidden backdoors, training might have been conducted improperly. This is, again, similar to the software supply chain attacks that we've been thinking about and have made headlines in recent years, but it's unique to the generative AI application structure. And both threats are particularly dangerous, right, because they're difficult to detect, especially through traditional testing methods. An AI might perform correctly on test data, but still have hidden vulnerabilities that haven't come out except under specific conditions. So to address the threats, my esteemed colleagues have proposed a 3-layer security framework. It is a proof of concept that works like a series of protective shields, kind of, around AI development. The first layer, being data integrity, is about tracking and verifying every piece of data and code used in the AI pipeline. It's like adding a tamper evidence seals, let's say. The second layer, real-time verification, continuously monitors operations as they happen. Instead of checking security at the end, right, it's verifies each step as it's happening, which catches the problems immediately. The third layer, model lineage, and this to me is one of the more interesting, and that's that family tree, really, of where the model came from. It records every component, process, change throughout development, making it possible to really to trace the model's complete history. That's where that provenance conversation comes in. So together, this multi-layered approach makes it a lot harder for attackers to compromise an AI application without being detected. So another thing I wanted to go into is just how the community is kind of rallying together to address all of these types of challenges through a few key initiatives. So these frameworks provide complementary perspectives, really, on generative AI security. And I think each brings kind of a unique perspective and value to securing applications. And these are really just a few of the groups. In particular, the OpenSSF AI and ML working group has done a pretty great job. If you go and check out that one, which I'll link to later, but they've documented in their meeting notes the activities of many of these other organizations. This is 6 out of at least 20 that I could probably think about off the top of my head. But everybody is kind of trying to identify gaps where new thought needs to be put into both the threat model and the mitigations. But we're just going to talk about these first 6. So the OWASP has the AI Exchange, right? The OWASP AI Exchange was founded to advance AI security standards and regulations. Project is structured as kind of a complete resource covering the complete AI security landscape. It is a very extensive document, and if I could spend the whole hour talking about this, but I'll just give a few highlights. Over 65 expert contributors, creating kind of a living document of best practices that gets revised on a consistent basis. And this document serves as input to multiple standards. EU's AI Act, the OWASP ML Top 10, and that sort of informs all of these kind of lists of best practices. So they distinguish 3 types of threats. And this is, you want to take one picture of a slide, this is probably the one, right? But you can also go find this on the OWASP website. So the 3 types of threats. During development time, when data is obtained and prepared and the model is being trained, and then the second, through using the model, providing input and then reading out the output, and then by attacking the system during runtime in production. And then they define 6 types of impacts for different types of attacker goals, right? To disclose, deceive, disrupt. So under disclose, another impact is hurting the confidentiality of the training data, which is should be a tremendous concern, I think, for all of us. And then the other one is then the confidentiality of model intellectual property, which, you know, depending on who you are, you may care more about. And then to disclose the confidentiality of input data. Then to deceive, hurt the integrity of the model behavior. Now this is a little bit different, right? The model is then manipulated to behave in an unwanted way in order to deceive the user. And then to disrupt, which is to hurt availability of the model, right? You want to damage the application so that the model doesn't work or behaves in an unwanted way, but not necessarily to deceive, just to disrupt the application. And then the 6th is both to kind of disrupt and disclose, and that's confidentiality, availability of non-AI specific assets. So the threats that create these impacts use different attack surfaces. For example, the confidentiality of training data can be compromised by hacking into the database during development time. But it can also leak by an inference attack, for example, that can find out whether a certain individual was in the training data simply by feeding that person's data into the model and looking at the details. So the diagram, it kind of shows the threats as arrows, and each threat has a specific impact. So anyway, this is a fantastic resource, and it's something that I think different security groups are going to be spending more and more time on, and that's just adjusting how we think about modeling the threats unique to generative AI applications. And then they also provide, as part of this, again, extensive document, a security matrix. And the AI security matrix organizes threats and controls by asset, impact, and attack surface. This helps quickly identify appropriate controls or mitigations for specific threat scenarios. And it also provides kind of a structured approach to that risk assessment. I would say this is valuable for prioritizing, you might say, and then it shows just, you know, all threats and risks ordered by type and impact, and you know, as a quick reference. So again, mitigations. The AI Exchange provides controls tailored specifically to generative AI applications, like, for example, input validation and segregation to help prevent prompt injection. Guardrails and oversight mechanisms limit potential damage from manipulated models. Detection controls help identify and block attack attempts. And it goes into further detail with more specialized documents, which, you know, again, we don't have time to go into here, but I strongly encourage you to look into this further. I also wanted to mention from OWASP the top 10 for large language models. Here's yet again another thing I could spend all day on, but I certainly won't. But this is the current top 10, and this is something that is revised each year. And this year, there were a couple changes. And one of the things that I really wanted to point out here, a couple things, frankly. The prompt injection, I keep saying that, and I want to make sure that I define what that is. And that's what occurs when user prompts alter the LLM's behavior or output in unintended ways. If you ask it a question like, you know, is the sky blue, and you get a question that is harmful or even just untrue, then that would be a prompt injection. The other one that I really wanted to talk about, though, that I think it's interesting that was included, though, is misinformation. So misinformation is an interesting type of vulnerability, right? Because I think people, again, I've mentioned that people take for granted the accuracy of the information that they're getting out of these language models and out of, you know, these kind of chat GPT type interfaces. Misinformation is when, you know, the LLM produces false or misleading information that appears credible, and that is problematic, right? So some of that can be from hallucination, where because of the nature of the application, the answers are provided based on a predictive situation, right? And when the model doesn't have the complete answer, it can fill in the gaps and it makes it up on its own. And if it looks believable and you do not fact check it, that is a potential harm. And it's interesting to me that that was included in the top 10 list of potential vulnerabilities for large language models. So I think that's definitely worth considering, the significance and impact of that. The other thing I wanted to mention is MITRE ATLAS, right? The MITRE ATLAS framework. So the MITRE ATLAS extends the existing attack framework to concept to AI systems. So MITRE has been around a long time. You may have heard about it if you were around security quite a bit. But it provides a taxonomy of adversarial AI tactics and techniques. It documents observed attacks in the wild. And it's particularly valuable, I think, for threat intelligence and attack simulation when evaluating machine learning model security. This is the full matrix, which you can, that's probably hard to read, but it's one of those things, again. My intention here is to kind of provide a list of things that I hope you'll follow up with later, and this is definitely one of them. And then you have the NIST AI risk management framework. So this was developed by the National Institute of Standards and Technology to help organizations address AI risk, right? What makes it particularly valuable, it's quite adaptable. It can be applied to any AI system regardless of complexity or sector or any of that sort of thing. Again, worth looking into. And it is structured around 4 core functions and their approach to AI risk management. So governance, mapping and documenting the context in which your AI system operates, measuring the risks, and then managing how you respond to the risks, right? So that's the basic structure of it. Implementing that NIST framework doesn't require kind of reinventing your risk management approach. You can kind of integrate it with your existing processes, and then while addressing the unique characteristics of AI systems. But so I wanted to introduce you to something completely new, though. So you might all be roughly familiar with organizations like OWASP or NIST. OWASP was founded in 2001. It's been around a long time. NIST, the National Institute for Standards and Technology, I believe was founded over 100 years ago. But there is a new project that I'm involved in, and it's only about a year old. And I would then like to, of course, introduce you to the security initiatives in that project, which I am currently leading and would love help with. But first, I want to give you a little bit of background on the project just for context. So again, as I mentioned, everybody's very excited about developing AI applications. We're sprinkling AI on everything. And in this environment of rapid innovation and the desire to produce generative AI applications, that part is a given, right? The desire is there. But when we're focused on that rapid innovation, especially in pioneering fields, right? That's what we're in. We're at an interesting inflection point in technology history. We may be focused on a goal, right? Getting that minimum viable product out the door and getting some functionality. But what's sometimes lost in that drive is the foresight to apply the principles that lead to interoperability, flexibility, and security. And in emerging fields where we don't have the luxury of having best practices from the people who have gone before us, we have to make it up for ourselves and come together to establish those best practices. And AI development really is kind of like the Wild West. Everyone's kind of reinventing the wheel, like the timeline I showed you earlier. Everyone's doing it a little bit in silos. And so what we'd like to see with this project is the adoption of community-established standards to smooth and speed up everyone's development workflows. So I think I skipped over the slide, apologies. That project is the Open Platform for Enterprise AI. This is an Intel founded project that was then later donated to the Linux Foundation. So I think we're all open source people here, and this is the open source way, right? We come together and we establish best practices together, and ideally in a vendor neutral way. But what happens when we get excited about pushing new technology boundaries, right? As much fun as we're having producing all this cool new stuff, we tend to focus on the end goal of getting there by any means necessary. Kind of what I alluded to in the beginning, where people are getting those generative AI applications because of external pressure. But that can mean we're constantly inventing the wheel. We're breaking a lot of new ground quickly, a lot of different options, a lot of paths to reach the same goal. And because we have so many options, we may end up like this disorganized pile of Legos here without a really reproducible way of working. And that, of course, has security implications too. But as a community, again, I think we can do better and benefit from what we're all learning in our silos and bring it together to forge, I think, a more standardized path. So this is, of course, an AI-generated image, and I think it's kind of cute. But so this is my representation of what we might end up with when we're out there breaking new ground and developing quickly. We might end up with something like this. It works. It might work well. But it might be hard to modify. It might be hard to expand. It might be hard to maintain. And you might want to start with something a little bit less unruly, lest you create a monster with a mind of its own. So the good news, of course, is that the open source community comes together like it does, and again, under the umbrella of the Linux Foundation, to work toward that interoperable standardization that we're working on to help us tame some of that chaos. So again, open platform for enterprise AI. It is a composable set of blueprints. The goal is to be interoperability, interoperable, vendor neutral, to allow you to choose any model, any framework, any vector database, and it is geared toward building RAG applications, which I will get to shortly. And it also provides, again, a large set of blueprints. I believe it's 22 or more different demo applications, but I'm about to show you another. I'm about to show you the one in particular that's more complex and more interesting. But again, I'm from Intel, but this is not an Intel project, not just an Intel effort. This is, all of these lovely folks have joined us on this platform to ensure that interoperability and best practices that I keep talking about. But before I get into the security stuff and more of it, I want to talk about what RAG is. Does anybody here know what RAG stands for in the context of AI development? Okay, cool. So I'm going to explain it with a quick example. If I were to ask ChatGPT, who is my mom, it doesn't know. Because I am not a famous person. I don't know, it might know Tom Cruise's mom, but it doesn't know who mine is. Because it's going to tell me it doesn't know, it doesn't have that training, it's not part of its training data. Since it is a pre-trained model with general knowledge, the only way for me to get the information that I want is to provide it context. So I'm going to have to provide it that context if I want to get an accurate answer. Now, why do we want to do this? A good example, I think, is the best example I usually think of is a customer service chatbot. You don't want, it's not going to do your customers or users any good to provide them a generic model with general information if they're looking for specific information specific to your product, your company, whatever it is, right? So you need to augment that general knowledge with something that is specific to a product, a company, whatever it is that you're working on. So how do we do that? In the most simple case, we provided the context manually as part of the prompt, right? And then it works, right? It can generate a response based on a novel topic. This time I said, hey, I gave it some information about who my mother might be. This is actually probably not about my mom, but whatever. And then it's able to give a more full answer. But how does that work? So in this case, I'm using my brain to extract the knowledge, and then I provide it manually for the chatbot. And that augmented the general knowledge that the model already has. And this is what's called RAG. The main goal of RAG is to have a prompt with enough information so the LLM can generate an answer based on the information provided. And when you break that down a little bit, there's of course it's not that simple, right? There's a complex series of events that leads from that question to the answer. So think of RAG as a two-step process. First, you need to pre-process and store your knowledge in a knowledge base. So for example, if you ask the system, who's my mom, the system is going to search for relevant context to answer that. To do that, an embedding model converts the text of your question into numerical vectors, which represent the meaning of the text. And then the retriever compares those vectors to the vectors stored in your knowledge base. Those vectors have meaning, and then they can be compared to find the most similar documents. Once it retrieves that relevant information, it can then re-rank the results before adding the context to the prompt and then feeding it into the language model. So of course this is complicated, right? These are just a few kind of concerns, but we'll see a lot of challenges to deploying these kind of applications with even a simple RAG architecture, right? What about the data, the LLMs, the deployment? How do you deploy this thing? Maybe we're using Redis, and now we want to change to use Milvus as a database. How difficult is that if we've built it, kind of flying by the seat of our pants without the flexibility in mind? There are a lot of models, right? There are so many LLMs. How do you choose one? And which frameworks do you use, right? And then, of course, you've got to deploy your application, and then you have considerations like hardware efficiency and that sort of thing. And then what guardrails, right? What guardrails have you put in place, or what do you want to put in place to ensure the things that we're talking about, like the correct output and that kind of thing? How do you ensure the accuracy of the results? And then how do the pieces work together? From an engineering perspective, how do you build this thing and make all of this, safe to use? But so that's where we're going with this project, right? If we start with a stable framework, we can have a nice little stable building instead of an unruly monster. And so what the aim is then to provide reference architectures as a starting point, which gives a more reproducible modular way of building things. All of those Legos that we keep seeing, right, can be, instead of an unruly pile, let's bring them back into microservices that can be easily plugged and played to give us a solid foundation. So this is a quick demo, and this is what the OPA demo, or the chat Q&A demo gives you out of the box. Let me just hit play. We're going to ask a chatbot a question about an event. And the model, of course, has some knowledge about the event, but it doesn't know specific details. Now, in this interface, we have the ability to add additional context via document upload, or in this case, what we're going to see is it's providing a URL. And that additional context augments the model's trained knowledge and is then, of course, able to give the more detailed answers. And this is a very simple way of providing the context, but it's just a starting point, and it provides kind of an architectural base for people to build upon. Well, okay, we can speed it up. I think you know what's going to happen here. We've taken the information from the website, and now we're going to get a better answer. So this is how that particular demo is powered, right? Each of these, each separate microservice is designed to work together to serve various functions within that chat application that we just saw for the Q&A. In this case, we have a user interface, the data supplying it, the microservices can point to one another, and other services and APIs. And now we're going to explore it just a little bit more. So here's a larger picture about how these kind of microservices interact and how they communicate with each other to provide this additional context. But then we also, we need humans to use this thing, so we need a user interface. So what we've done is we wrapped it in a mega service so that grouping it in this way provides a communication gateway between the mega service and a front-end UI. And that gives you a full application that humans can then actually use. We do not expose the individual services to the UI, so it provides a communication to the UI and then handles communication among the various microservices. There we go. So so what have we learned, right? RAG is a great solution for providing contextual answers. If you need to build a chatbot app, customer service, this is that knows all of your proprietary information. You cannot rely on just a large language model with general information. And then by using this more structured approach, you can get started, shorten the path a bit to a minimum viable product, but also try to ensure that we are using best practices, which go back to the whole security conversation. But obviously there are challenges, right? Different types of data, large amounts of data, and this is the type of work that we're trying to do as a community to address. So what is the point of all of this? The point of all of this is that we would like people to join us to solve all of this, right? You can come together in the OPA security working group or other working groups, and we would love to join you. But we would love to join you in solving the problems. And if you don't find what you need in the repo, of course, it's an open source project, and we'd love for you to create it. So there are a lot of ways to participate in the project. You can get everywhere from here, but the most important one I want everybody to take away from this one, sorry, I'll give you all a chance to take a snapshot of this, is the security working group. And that's what we're here to talk about, right? So this is yet another group, that a community initiative coming together to solve the problems of AI security. So why this group versus other groups, right? What does this group provide? It is a newer project, so it is a fantastic opportunity to get involved and kind of shape the direction of the way that we are looking at generative AI security, and shape the direction of its security community itself, and shape the security of the project that provides reference architectures to other developers and engineers. So right now we're currently focused on defining how threat modeling for projects built on OPA itself might work. And we are setting the direction for the project security itself. We're also working specifically to identify the gaps in the work of other AI security groups to put our efforts where they are most needed. So if you have investigated any of the other security communities, be it OWASP, be it COAST AI, be it OpenSSF AI ML, which I haven't quite gotten to yet, but if you've been to some of those and you're looking for a place to have a different conversation, well, that's what we are, right? We are here specifically looking at the unique use cases of building RAG applications, and we're creating an environment where we share knowledge with each other and establish the best practices necessary for tackling these tough generative AI problems. And I would love for any of you to join us to help solve them. So the other one that I wanted to mention before we go away is the OpenSSF AI and ML working group. If you're not familiar with the OpenSSF has been around for a few years now, and it's focused quite a bit of energy on software supply chain security. And of course, under that umbrella fits AI ML. So again, while you're investigating the intersection of security and AI, I would strongly encourage you to check out the AI ML working group at OpenSSF. It's a great and welcoming group of people. It also provides a tremendous resource for keeping tabs on what else is going on in different AI ML security communities, because there are many, because the problem is complex, and there are different areas to focus on, and each different group is identifying its own gaps as it relates to that group. So this is yet another one that I would love for you to check out, and then jump over and join us in the OPA security working group. And before I leave you here, I would be remiss if I did not mention one of Intel's contributions, which I think is actually quite interesting, was recently open sourced. You can find this on GitHub, and that is the Large Language Model Adversarial Robustness Toolkit. I would encourage you to check this out. I am myself in the process of checking it out, and I would love for you to check it out and come back. Find me on the internet or find me in the OPA security working group and tell me your thoughts on it. I would greatly appreciate that. So as I keep saying, find me and join us in this great fight for generative AI security. So here's how to do that. You can find me at any of these places. I would love to help you get involved in some of these AI security communities, and that's a little plug for my podcast. And now I think we have time for questions. I think I blew through some of that. We could, if there's time and interest, I go back and drill down more into the OWASP top 10. The reason I didn't and glossed over it a tiny bit is because I was afraid that we don't have internet access and we can't drill down into it. But I would love to try if anyone is up for it. And that is here. Any questions about anything you've seen here, or possibly how to get involved in security communities, or why you might want to? Yes, right there. Yes. Yes, potentially. Sorry, I'm gonna come over there. I think I'm not supposed to wander because there's video, but I'm gonna do it anyway so I can hear it, and then I will repeat your question for the recording. Okay. Ah, yes. What is prompt injection? So let's drill down. Let's hope we have a good enough internet connection, because the OWASP documentation will say it far better than I will. But prompt injection, the beginning of it is, it's when a user prompts alter the behavior in unintended ways, right? Oh, it's not there, sorry. Yes, exactly. Yes, thank you for that. Yes, thank you. Sorry, one sec. I need to figure out how to show you what I see. Hold on one second. I'm trying to figure this out. I'm looking at something that y'all are not seeing, and I'm going to figure it out. 1 second. Okay, now where is it? There we go. No, I can. Okay. Anyway, but yes, exactly what he said is when you alter a prompt that creates unintended consequences, which could mean, for example, it could be intentional or unintentional, right? A malicious actor is trying to exploit the model, maybe get data out of it that it's not supposed to share. That's one example, right? The other one is just you inadvertently trigger something that wasn't meant to be triggered. So that's that type of a prompt injection, and it can potentially disclose sensitive information. Oh, that's showing my notes. Hold on, sorry, 1 sec. PowerPoint challenged here. Help. This is not at all what I want y'all to see right now. Hold on 1 second. I can't bring up the... There we go. Okay, we're back. Sorry. So yeah, so that's basically what a prompt injection is anything you put in that gives you something out that wasn't supposed to come out. And that can be used for different reasons, right? You can, maybe your goal is to get out information that is confidential, that isn't allowed to be shared. Maybe it wasn't your goal at all, and maybe that's what happens anyway. Output handling is also an interesting one, right? And that is, if, just like any other kind of field, right? If you are improperly sanitizing and validating what is shown to the user, that can also have unintended consequences. Perhaps it grants privileges that it wasn't supposed to, or it outputs things that are harmful. Yeah, anyway. But yeah, output handling, I think because of the unique nature of generative AI applications, has to be addressed in a far more complex way than any other type of application. So. And it can lead to prompt injection as well. Sorry, any other questions? Pardon me while I struggle with my PowerPoint. Thank you.
111. All right, sounds good. All right, let's begin. So this talk is called Atomic Honeypot, a MySQL honeypot that drops shell. This is the presentation that me and my colleague did at DEF CON in 2024, but this is actually a bigger one, a full version of that presentation. So, my name is Alexander Rubin, Alex, and my background is MySQL. I have been working for MySQL AB since 2006. I worked for Sun Microsystems Oracle doing MySQL consulting, and I joined Percona 2014, and I joined Amazon Web Services about 4.5 years ago. And I first joined as database engineer, working on RDS. And then at AWS, I created a new team, which we called Red Team. So security was my hobby over the years. I started playing Capture the Flag games. And currently, I'm managing this Red Team. We call it RESEC, Relational Security Red Team. So this is our agenda for today. We start, the part one is about honeypots, MySQL honeypot specifically. So I assume everyone knows what honeypot is, right? So we started with looking at different attacks attacking database servers. And then from there, we created what is called high interaction MySQL honeypot. And then we wanted to see what we can do with those attacks. Our goal was to learn more about the attacks and maybe even download the code, the evil code that attackers are using. So we have used this new vector. And this new vector we actually presented about 2 years ago, 2023. This vector is called MySQL Server Can Attack You. So I did a number of presentations about this vector. And basically, if you are a client and you connect to a rogue server, then this rogue server can actually attack you. And I will talk about that in part 2 today. And then finally, we have created this atomic honeypot. What atomic honeypot is doing, it is using this vector. And with a server, honeypot is a server. So it will push something back to the client and try to attack the client. So our goal again is to interact with those bots and maybe download the evil code. So let's start with the beginning. Database servers are under attack. Bots, this is really bots. It's not humans. Bots are everywhere. They're scanning the internet. They can see, they find a server, a MySQL server in this example, and they will try to connect and do various things. So, if you expose your MySQL server on the public internet on port 3306, depending upon where you're running that server, it may take from 30 minutes to a couple days for those attackers will find your server and try to do something bad with it. So we did the same thing. We created a Honeypot server. So the idea is simple. We start something in public internet and just wait. Someone will come and try to attack. But here's the catch. Usually, if you want to do a honeypot, the easiest way to do is to just start something that will be listening on that port. But this is not the case with MySQL protocol. MySQL protocol, unlike other database protocols like Postgres, is server initiated. So if you start some listening program, the client will not be able to connect. The client will need a prompt. And here's the prompt, right? You telnet to your MySQL server, and then you see it. Basically, you need to provide the server version. That's a part of protocol. You need to provide a server version. You need to provide salt. You also need to provide authentication plugin. So just listen is not enough. We need a real database. Now, you can start a real database, but then we really want to fake something, right? If it's a real database, then the attackers will come in and try to delete stuff. What would you do in this case? Would you allow it or don't allow it? So what we found out is it's much easier to just simulate MySQL protocol. So to create a honeypot, we used this fake MySQL server written in Python. It's called MySQL Mimic. It's open source, and it's really easy to use. So you can create a server, you can simulate MySQL protocol. So here, we can start our honeypot on open internet server. And then we can start collecting some interesting information. MySQL protocol has these connection attributes, similar to user agent in HTTP. So you can see what it is. It's platform, client version, operating system, and stuff like that. There are lots of interesting information here. And we have been looking at those attributes, and we start collecting those, and we can see those attributes are actually associated with a real attack. We can see what they're using. Some of them are using Windows, some of them are using Linux, and we can actually see that. Lots of useful information. So that was our first interaction with attackers. Now, we have identified two major attacks on MySQL server. The first one is attempt to own MySQL server. So what they want to do is they connect, they want to escape, they want to do a database escape and get a shell on the host itself, right? It's write a shared library to a plugin dir. This attack is actually unlikely to succeed right now, really unless you're running really, really old, like 10 years old MySQL server. And then the second one is more interesting. Second one is a ransomware attack. So when it connects to a server, it will try to delete all the data, all the tables, all the databases, and replace them with a ransomware node. So basically, it creates a README table and README database, and inside of that README database, README table, it asks for ransom. So now, let's go back a little bit. So here's what we see here, right? Connection attributes. We can see that the first attack is coming from Windows. It's using a very old version of client version, right? 5.6.14. But then the ransomware attack is coming from Linux. It's using libmariadb. This is a plugin, a client. It's a client name, right? And then it uses relatively recent drivers. We can also see that it's using MySQL dump utility. Why it's using MySQL dump? Well, a ransomware attack basically say, we get all your data. We downloaded your data. pay us a ransom, and we'll give you data back, right? That's why MySQL dump. MySQL dump is a backup program, and we can see more later on. So now we started thinking with those two attacks, can we actually use our vector to attack back, right? And then this has started this project, Atomic Honeypot, a honeypot that tries to strike back. Now we're here, part 2. I will talk a lot about this vector where MySQL server can attack you. I will actually demonstrate 3 different attacks that one can use right now. And there are lots of demos there. So before we'll go to the final part, Atomic Honeypot, we will spend lots of time looking at this specific vector. Now, we have been started juggling with the CVEs. Some of the CVEs we have found over the years, some were existing CVEs. And we are trying to find out which one we can actually use. So how does MySQL server attacks MySQL client? 2 major things. The first is MySQL client arbitrary file read. Very well known, very old attack. Basically, on the connection, MySQL server can request a file from the client, and then the server will read a file from the client, arbitrary file. The second attack is actually more interesting. It's a remote code execution. We presented that, we found it in 2023 and presented it at HIT-B in Amsterdam. So this is more interesting attack, and I will talk more about that. And then finally, there is an attack on MySQL dump that we will talk about next, after that. So let's start with the MySQL client arbitrary file read. Again, it's a very old method. Client can read any file from server. Let's see how we can do that. The open source tool is available. So you can just download this Python code, Python server. That's again fake rogue server. Basically what it does, for any connection, for any query, it will say, give me the file. And let's look at this. I have created this recording. Let's see how to start it. So here we have downloaded this rogue server. We start that rogue server on port 3306. And then here we connect to that rogue server. We just need to connect. We don't need anything else. This is old version 5.7. We connect to that host where our rogue server is listening, and that's it. Nothing else is needed. We just connect. So basically, it replaced the normal select version or whatever this client is doing to the load data locally in file. And then we obtained, in this case, we obtained etc password. But we can get any file that is readable by that MySQL client. Okay, so next is to demonstrate, just to demonstrate that this is not possible. My bad. Not possible in the latest version. This is version 8.0.37, and that has been fixed in that version. So if you will use it, again, it's client, it's not server. Server is fake. So we connect, and then it doesn't do anything. It doesn't manage to obtain that file. So now I do select one, and then I can actually see what's happening. This is the fix, right? So it cannot request the file. So the next thing, the next CVE that we will be talking about is remote code execution. This is the one that we found in 2023, and I'll talk in more details about that. So, to really understand how it works, we need to understand MySQL protocol. And here is the MySQL authentication phase of MySQL protocol, oversimplified. So let's say we have a MySQL client connect to the server, and MySQL client will say, hello, MySQL server, authentication, please. I have username and password, and by the way, I will be using this plugin, and the plugin name is MySQL native password. So the thing about MySQL is, MySQL allows you to create a pluggable authentication. So you can write your own authentication plugin. And plugin is a shared library. So in this case, MySQL server will say, okay, very good. I loaded that MySQL native password, and I check the username and password using that plugin, access granted. But now imagine another situation. So we have another client, and this client will say the same thing, but then it will say, I use whatever plugin. Now the server doesn't know anything about this whatever plugin, so it will try to negotiate the authentication. So it will say, let's try another plugin. So the client will say, okay, I'll try to load that plugin if I have it. So again, whatever plugin and another plugin is just a name. But let's take a look at the code, what happens here. So we can clearly see that the plugin name is used to generate the path and just do deal open on that path. So here's what we have. The name, the plugin name comes from the server. The plugin dir is a hard-coded variable that the client uses, so you cannot change it. And then there's an extension, different extensions on Linux, on Windows. But what is interesting here is that whatever it will create, whatever path it will create, using this name, the plugin name, it will put it into deal open. So what if we will do this? It's a directory traversal. So we will pass this name, the plugin name, from the server to the client, and the client will follow and do this thing, right? So there has been a series of findings about this. The original was from 2019, and we have found stage 2, I would say, or bypass of the original fix. So you can, in 2023, so you can still do this. So it's an arbitrary code execution via directory traversal. So this picture explains in more details how this whole thing works. Right? So our bad actor needs to upload a shared library. Actually, it's interesting that this SO file can also be bypassed. If you create a buffer long enough, then we have this sort of length overflow. And then you can actually load any file with any extension. So our bad actor will upload that file. File name and location doesn't matter. And the fake server will send the plugin name with the directory traversal and this length overflow. So here's the quick demo of how it actually works. So my colleague Martin sent me this resume, and it's not really a resume. It's a shared library, right? And this shared library will start a calculator. So I run my rogue server here. I will calculate the exact path so that I can load the PDF instead of SO. And then I use my Workbench. Workbench is a client utility. I use it on Mac. This is an old version, really old version of MySQL Workbench, and then I just establish the connection. Let's imagine this is a hack database. I have this plugin dir here, and then I'm trying to connect to my hack database. And let's see what happens. That's it, calculator. So basically, this demonstrates that there's an error here, right? But that demonstrates that you have been pawned with this. You connect to a rogue server, a server that you think that belongs to you, but actually was hacked and replaced with a rogue server, and now this bad actor, this hacker, basically have everything on your laptop. So this is a pretty interesting thing. And then finally, in this presentation, it's called new released, but in reality, it was released in 2024. We sent that to Oracle. Oracle has fixed that. It's been around a year since the Oracle has fixed that issue. So what this thing is about? MySQL has this database backup program, very well known, called MySQL dump. I guess some of you have used that. And this client utility, it creates a logical backup. It's actually produces a set of SQL statements. And those SQL statements can be executed and will be executed. So how does it usually being used, right? You need to create a backup, then you restore your backup. Or there's another way, you create a replica. You use this MySQL dump utility to clone your primary server to a replica server. It's a text file, right? It generates a text file. In this text file, there is an insert statement, right? But there is a catch here, right? And we'll talk about that. So here's the common way how a documentation, MySQL documentation recommends you to use that. So you connect your MySQL dump to your local server, and you do pipe, and then you do MySQL command line client, and connect it to remote host. Basically, you copy one server to another server, the data from one server to another server, right? But the thing is, this MySQL command line client supports this \, exclamation mark. And that actually executes the command. So, is it a text file or is it RCE? It's a RCE with a text file. That's super interesting, right? So, what if we will somehow find a way where we can inject that command into a server where MySQL dump will create a backup. So usually, MySQL dump doesn't trust the data that is received from the server. There are some exceptions. Remember the MySQL protocol. MySQL protocol has a version string. So MySQL dump client code, this is the example in the client code, it will read that version string and put a comment into your output file, version something, right? It needs just to let administrator know that this backup has been created from that server. So what if we'll create a rogue server again and replace this version string with an exclamation mark and then the command? So easy. It's one line div, right? Then you recompile your MySQL server, and then everyone who will be using MySQL dump will pretty much create a time bomb, because they will create a backup with this command. And now whenever they will try to restore it, they will basically means that we will own that. So this is super, super interesting. So, right? So basically we created this honeypot server, well, the rogue server, and added this injection. So now, to demonstrate it, you can just do a telnet, and you already see it. You already see it here, right? And then when you do MySQL dump, whatever the database name, whatever the username, whatever the password, doesn't matter, it will always put this. So here we just demonstrated with a touch creating a file on Linux, right? But that in reality it will create a backdoor or something. And then going back to Atomic Honeypot, we have created this rogue server, and we implemented those two things. We implemented the CV 2024 with a MySQL dump command injection and CV 2023 with a rogue MySQL plugin. So now let's really see what we can do the atomic version. And our goal again is we wanted to see what this code is, what it is. Is it like bots or what they're using? So before we'll go further, I wanted to really demonstrate the MySQL dump thing. So how is it supposed to work? And then we created a version for Windows. This is our payload. We started this honeypot. Honeypot will execute the string to download and execute this Visual Basic code. Right, again, this Visual Basic. I start the HTTP server, and then I use MySQL dump. This is older version of MySQL dump, which is vulnerable. And then I connect, that's it. You have been pawned. So basically, I connect to MySQL, I pipe that result to a MySQL server, basically simulating a situation where I want to copy one server to another server, maybe for application or for something, right? And then that's it. A client, not the server, a client executed this code. All right. So now, finally, we are here. Atomic Honeypot is dropping shells. So we wanted to really focus on those two attacks. We have been looking at this attack number 1, and see what we can do here. And again, we have 3 CV at hand, and we have been trying to figure out, can we use any of those? Looking at the fingerprints, we already know if we can use some of them or if we cannot use, right? It's old version, so arbitrary file read will probably work. RC with a plugin, we don't know. Maybe. We need to upload something to the server. That's the main limitation of this attack. And we don't see MySQL dump, because MySQL dump will present itself in the connection attributes. So let's see if we can use this client arbitrary read. So we have been trying to first understand, it's coming from Windows. We try to understand which Windows version it is using, right? And then here's the options that we can use. We can download those files and see. And the result is that this is really old version. It's Windows Server 2003. Maybe it's Windows XP, I don't know. Probably not. So this is very interesting as well. So now we wanted to try the remote code execution. And then we were thinking, maybe we'll do the simulation. And here's what we can do, right? If we want to do this, if we want to do it on Windows, we need to create a shared library. We need to create a shared library which will actually do something. This is an example of the DLL on Windows. So the challenge here is how do we push the DLL file to attacker server? Now, let's take a look at the queries that we have collected via the Honeypot. Because on the Honeypot, we can see everything that those guys are doing, right? These bots are executing. So we see this. This is the part of the attack. It's pretty much assumes that your server is Windows, and then trying to upload some program there. And how does it do the upload? It uses FTP server. It uses a public FTP server to basically upload into the, well, download, upload, I don't know, right? From that server. So actually, we can see that they're trying to do that from their client. So their client is running FTP server. So this is super interesting. Imagine, this is simulation, but imagine that we can use the FTP server, upload the DLL there, and then create the rogue server, the rogue atomic honeypot. It will connect, will push the plugin name, which will point to the actual path that we have uploaded, and we'll have a command execution. So here's how this simulation, this attack could have been done. So imagine that we are running FTP server on Windows, and we have a demo and demo. And then we put a file, right? This FTP server, we assume that this FTP server is on those attackers' side. So we upload the DLL to them, right? Because we know that they're running it. We know the username and password. All right, so we assume that this is a FileZilla FTP server. Okay, we uploaded the file. So the next step will be to execute that, push this plugin dir, push that plugin name, right? So then we launch this honeypot. And this is the code of the honeypot. We put this plugin directory string to point to the file that we have uploaded. And then plugin dir, this is the file name that we have uploaded again. And then we launch it. We wait until those attacks will connect. And this is what our DLL looks like. This is how our DLL looks like. Right? We want to execute a code there. So finally, it's a long demo. Finally, we will assume that they will be using some client connection. So we use MySQL command line tool to simulate it. And here you go. You have been pawned. So this is the simulation of what we could have done to those bad guys. And then recap. We have been able to do an arbitrary file read, and then we did a RCE via plugin. And then the attack number 2 is where we actually succeeded. So we have been looking at that, and we can see it's a new version of libMariaDB, which is pretty much the same as libMySQL, a client library of MySQL. So we can see that we can not do arbitrary file read. because it's newer. We cannot do RCE via plugin because it's also the newest version. But we do have MySQL dump. So maybe we can use that RCE with MySQL dump. So again, we have been analyzing what kind of queries these attackers are running against MySQL server. And here's what we see. Right? This is the fingerprint of MySQL dump. But what is interesting here, the super interesting part of this select star from transaction, limit 10. So they're actually only taking 10 records out of your tables. Again, this is ransomware attack. So if a ransomware operator will tell you, give me that amount of dollars in cryptocurrency, and I will give you your data back, then your next question is, prove me that you actually have my data. They will give you 10 records to prove. They are not downloading the whole thing. This ransomware attack is not downloading your data. And it's actually logical from their perspective, right? If you downloaded terabytes of MySQL data you need to store somewhere, you need to send it to the storage and stuff like that. They're just downloading 10 records to prove. So don't pay. Don't pay. They don't have your data. But back to the Honeypot, here's what we can see here, right? So it creates a table README, it puts the Bitcoin address there, have backed up all your database and stuff like that. So the question is, we started brainstorming. Again, can we download code via arbitrary file read? No. Can we execute code via plugin? No. But then we started thinking how this attack is designed anyway, right? How do they connect to the server? How do they do that? There's MySQL dump somewhere. And MySQL dump is a client utility. So we have been thinking, we see MariaDB connector, that should be an application somewhere. Then we suddenly see MySQL dump. So probably there's a CLI. It's on Linux, right? So it's CLI on Linux, so they probably do exec. They execute a MySQL dump from that client program. And then we see MariaDB connector again. So now we started experimenting with different database names and different tables. Again, we see everything that they're sending back. And then we see they send our table back. This is a fingerprint of the MySQL dump. So they send this back, and then we start thinking, maybe we can do a command injection here. If the code is not robust enough, no one did a code review for those bad guys, maybe we can actually do a command injection. Actually, it is a command injection. So we totally failed. Execute any of the CVEs that we found on this attack, but we succeeded via the command injection. So basically, here's an example how you can read something without executing code on that side. Right? So you create a schema name, and we do a PS, and then we do base 64. This is the schema name that we will send them. They will build the MySQL dump command line and put this schema name, a database name, as a part of that command line. This will be executed and will send back to us. So now we can see and we can download this whole code, right? We can also do in PS, we can actually verify that this is how we thought it works. So this is the command, the PS command is coming from the actual code. And we downloaded this evil code, this evil code is written in Python. It's actually targeting, it uses MariaDB connector. We already knew that. It's also interesting they're doing mass scan. They're brute forcing the password. And for every password they found, they execute this payload. Again, the goal of this attack is ransomware. But this is what they're doing. Run with a timeout. It's the simplest command injection possible. You can do anything you want with this. And there are probably multiple injections. And also it targets other data. It targets MongoDB as well. So that's it. If you want to try it at home, then you don't even need this code. What you can do is you can create a database, like you sacrifice your database, right? But you create this database, and then you create the MySQL server, right? And then you put the database name. You can do a semicolon command, semicolon. You can also do this dollar trick in bash. Either of those probably work. When you create a database and tables in MySQL, it needs to be enclosed with a backtick, so don't forget to do this. And that's it. So summary, I have demonstrated today three vectors, three CVEs. One of them is the newer CVE found in 2024 in MySQL dump. We have created atomic honeypot, and we created atomic honeypot that actually can attack and stop the attackers. And this tool will be released soon. Hasn't been released yet, but hopefully it will be released soon. So that's it. Any questions? Thank you. Yes. Yeah. Correct. This is just an example. You can do schema name anything here, right? This is an example. We wanted to basically prove our theory without doing things, right? But again, this is what you can do, right? You can create database, semicolon, command, whatever command you want to run. You can execute any command on those servers. Those servers are actually bots. Yeah, good. Yes? Right. That's why we didn't do any attacks, right? We just downloaded the code. We haven't executed anything on their side. Our goal was executing the code. But looking at the code, we believe that this is the infrastructure that they are setting up. This is not the, we have been thinking about the same thing. We should not attack those, right? That's why we did a simulation in the first one as well. So, but looking at the code itself, we believe that this is VPCs that they set it up. Yeah. Sure. You had a follow-up, or yeah, go ahead. So when we start a honeypot, we can see whatever they are sending. We analyze this. This is MySQL protocol. We can look at the queries, the exact sequence of the queries that they're running, right? So this is how we figure out about the MySQL dump thing. Or your question is more about the CVEs? Yeah. yeah, yeah, there's, yeah. I don't actually remember how long it took us to do that. Maybe a month or so for this POC. But we were creating this POC for the conference primarily. So. Oh, they are not using CVEs. They are not using CVEs. They are using, well, they are using CVEs in a sense, but the second one is not using any exploits, right? The second one is just brute force the password, connect, drop the databases and stuff like that. So we see all the queries, we see all the sequence. So they are not, in the second attack, they are not using any CVEs. We are trying to use we have been trying to use something in MySQL dump to basically read an arbitrary file. That's pretty much it. How long it took us to develop? I think about a month. Other questions? All right, thank you very much.
Test. Hello. Check. Yep.
Hello.
Check, 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 check. 1, 2, check, check.
Yeah, that was whatever happened, they did it upstairs. Okay, thank you.
Test. We all set? May I start? Okay. Hello, everyone. Before we start, I just want to say that today is 8th of March, which is also International Women's Day. At first, I would like to wish everyone a happy International Women's Day. Thanks for joining on a Saturday evening. Well, I really don't know whether I should be proud of or terrified that you guys are coming to Cloud and Application Security Talk on Saturday evening. But thanks for joining, thanks for coming here. My name is Murat Aydemir, and today we will talk about securing our web applications against OWASP top 10 threats in AWS Cloud. Before we dive into today's presentation, let me briefly introduce myself. Once again, my name is Murat Aydemir, and I am working as a Security Delivery Associate Manager at Accenture Prague, Czech Republic, and focusing on both security in the cloud and security of the cloud, basically covering cloud and application security. On the application security side, I focus on dynamic and the static analysis, conducting penetration testing engagements and the red team exercises for the dynamic part, and also performing security-focused or, let's say, offensive source code reviews for the static part. On the cloud security domain, I have been acting as a cloud security architect for last few years, while also contributing to cloud security assessments from time to time, not always, but let's say from time to time. In my free time, I do vulnerability research for mainly web and web-based technologies, and so far I have discovered and reported over 30 CVs/zero-day vulnerabilities across various vendors, including Dell, SAP, Zoho, ManageEngine, Siemens, Barco, and so on. I am also a huge fan of the serverless concept and the cloud-native solutions. Well, as we go through today's presentation, you will likely notice how much I like the serverless, because most of the architectures we will design and discuss today will revolve around serverless principles. And lastly, I enjoy a lot to reproducing either documented or undocumented end-day security vulnerabilities and perform root cause analysis for them. Frankly, I generally do this certain vendors and their well-known products, which are heavily used by the community, and I generally do this only for high severity or, let's say, niche-ish type of vulnerabilities, such as zero-click RCEs or unusual remote code execution cases, fully account takeover situations, insecure deserialization, and so on. I document and share some of my analysis on my GitHub profile. If this type of works interests you, please feel free to check out my GitHub profile for some of my work. All right, what should you expect from this session today? Well, at first, we will start discussing about security topics in the cloud era. Then I will try to explain OWASP and the OWASP top 10, especially from the penetration tester's point of view. And we will design our core architecture. Afterwards, we will do some architectural exercises to make this solution or architecture more secure and resilient, especially against OWASP top 10 threats. And finally, we will finish up with some detection-based AWS native defensive strategies. All right. When we talk about application security for cloud-based applications, there are several security topics that come into play, or let's say there are different security understandings as a term. That's why, to ensure we all are at the same page and speaking the same language, I will try to explain some of these security topics. And this will lay a strong foundation for the rest of the session. That's why I would say this part is slightly more important, or let's say the crucial than the others, especially to having a better view of the whole session, or let's say in general cloud security. Our first security topic is security of the code base. In this security topic, we look for an answer for how can I develop more secure and bug-free codes. As you understand, this area, this topic is nothing but purely at source code level. Our second security topic is security in the cloud. In this topic, we aim to answer a key question, which is, how should I design my cloud-based application in order to minimize the attack surface as well as reduce the number of possible attack vectors? In this domain, we are more into decision boundaries or trust boundaries, data flows, risk assessments, threat modeling, and so on. Actually, it is all about building an application that proactively addresses all security concerns at every stage of the SDLC lifecycle. And our third and last security topic is security of the cloud. In this domain, we are basically focused on building secure, robust, and reliable cloud infrastructures. We are more into data encryption at rest or in transit, network and perimeter security, identity and access management, logging and monitoring for threat detection, or even logging and monitoring for visibility. Since we want to protect our web applications against OWASP top 10 threats, today our focus area will be security in the cloud. But you will see that while we do this, we will not going to touch the source code or the code base. Instead, we will rely on some cloud native services, more specifically AWS native services, to protect our web-based workloads against OWASP top 10 threats. And this approach will allow us to address all possible OWASP top 10 security risks effectively, while also maintaining the integrity of the source code or code base. Okay, now let's talk about OWASP. OWASP stands for Open Worldwide Application Security Project. It is a globally recognized non-profit organization dedicated to improving software security. OWASP operates under open community model, which means anyone can participate in and contribute to OWASP's project. And there are many, many active projects on the OWASP sites, such as OWASP cheat sheet series. This project is a collection of the short guides which designed for mostly either software developers and software architects to help their secure software development lifecycle. And there are plenty different cheat sheets under this project which are focused on different areas and the domains, such as input validation cheat sheet, logging cheat sheet, authentication cheat sheet, session management cheat sheet, secure file upload cheat sheet, and even Docker security cheat sheet. Another promising project from the OWASP side is OWASP AMAS. AMAS is basically attack surface mapping and the asset discovery tool, and it supports both passive and the active recon from many sources, such as public DNS records, public MX records, search engines, APIs, and search engine crawlers. And we generally use it during a recon phase of the penetration testing engagements or red team exercises. We have also OWASP ASVS, or Application Security Verification Standard. It is a framework for the testing the security of the web applications. It provides clear set of the security requirements to help developers, testers, and the security teams to assess their web applications security. And similar to OWASP ASVS, we have also mobile application security testing guide. It is a comprehensive resource for the testing the security of the mobile applications. Unlike the ASVS mobile application security testing guide, only focus of the mobile applications regardless of the application development platform, either iOS or Android. It also provides step-by-step methodology and the test cases for identifying security vulnerabilities in both iOS and Android applications. I mean, in a nutshell, there are many active projects on the OWASP side, but today our focus area, or let's say our focus project, will be OWASP Top 10. OWASP Top 10, or as known as OWASP Top 10 for web applications. At this point, there might be some misunderstandings because there are other top 10 lists on the OWASP site, such as OWASP Top 10 for API, OWASP Top 10 for mobile applications, OWASP Top 10 for CI/CD pipelines, and even OWASP Top 10 for large language models. But please, every time when I say OWASP Top 10, please interpret as OWASP Top 10 for web applications. The first OWASP Top 10 released in 2003, and the latest one released in 2021, and it was the 7th iteration after the first version was released. But there is a good news, which is they are planning to announce a new release of the OWASP Top 10 in the first half of 2025. OWASP Top 10 is a flagship project of the OWASP and also one of the very, very first projects from the OWASP side. It just focuses on only security risks, not OWASP Top 10 impacts, not OWASP Top 10 likelihood or vulnerabilities. It just focuses only the security risks. But please keep that in mind. OWASP Top 10 represent literally the bare minimum to cover application security. So what does it mean? It means there are many things to do. There are many best practices to implement for web application security. But once again, OWASP Top 10 represent literally the bare minimum to cover application security. Or you can interpret OWASP Top 10 as a baseline, or I always say that OWASP Top 10 is a must to cover basics and the fundamentals of the application security. Now let's take a look at the OWASP Top 10 categories. And our first category in OWASP Top 10 is broken access control. This category includes security issues like violating the principles of the least privileges, parameter tampering, insecure direct object reference, or either metadata manipulation, and so on. The second category in OWASP Top 10 is cryptographic failures. This category uncovers security issues like unencrypted and plain text communications, use of weak TLS chipper suites, or use of cryptographically weak hashing algorithms such as MD5 or SHA-1, or even use of insecure and outdated padding methods such as PKCS number 1 and something similar. Injections rank third in the OWASP Top 10, and I think this category is the most known one among the other categories. This category includes vulnerabilities where user-supplied data is not verified, filtered, or sanitized by the application in a secure manner. And some of the common injections we can mention under this category are like SQL injections, LDAP injections, OS command injections, or expression language injections. The fourth category is insecure design, which refers to flaws in the overall architecture of the application. These issues stem from a lack of security consideration during a design phase of the application, or let's say SDLC lifecycle. To be honest, it is slightly harder to detect insecure design-related vulnerabilities compared to other OWASP Top 10 security risks, because to detect most of the OWASP Top 10 security risks, traditional methods such as dynamic and the static analysis, or let's say the penetration testing engagements and the security-focused source code reviews would be fairly enough. However, and unfortunately, to detect insecure design-related vulnerabilities, we need to conduct proper threat modeling to address these security issues. At number 5, we have security misconfiguration. Security misconfiguration-related vulnerabilities happen when the systems, servers, or the applications are not configured properly in a secure manner. For example, missing appropriate security hardening across any part of the application stack, or improperly configured permissions on the cloud services, enabling unnecessary features on the web server or the web application itself, default accounts, and default credentials. The next category is vulnerable and outdated components. This category highlights the risks of using outdated software libraries, frameworks, or dependencies. For example, use of vulnerable JavaScript libraries on the front end of the web applications, or use of vulnerable and outdated backend frameworks such as Spring, Spring Boot, Fast API, Django, ASP.NET, or .NET Core. Another category in OWASP Top 10 is identification and authentication failures. This category includes security risks and the vulnerabilities such as missing brute force protection mechanism, or the absence of the multi-factor authentications, use of weak or insecure password reset and the forgot password functionalities, passing session identifiers through URL, and so on. Another category is software and data integrity failures. Applications which relies upon plugins, libraries, or modules from untrusted sources, repositories, or the content delivery networks are common issues we can mention under this category. At number 9, we have security logging and monitoring failures. This type of vulnerabilities arise when the application failed to log a critical event or not alert for suspicious activities. For example, missing logs for failed logging attempts within a specific time frame, which we call as a brute force, or not alerting on unusual traffic patterns. Finally, at number 10, we have server-side request forgery, or SSRF. SSRF is such a vulnerability that allows attackers to force server-side application to make a request to unintended locations. Frankly, SSRF is one of my favorite type of vulnerability, especially when I'm conducting penetration testing engagements, because once you exploit SSRF successfully, it might give you a lot of useful information for both target application as well as the underlying the infrastructure. All right, that was all about the OWASP Top 10, and now we can focus on our core architecture and the architectural exercises which we will do pretty soon to protect our web-based workloads. This is our core architecture, and basically we have EC2 instances behind AWS ALB, which are deployed to different availability zones, AZ1 and AZ2. In similar way, we have Amazon RDS database instances for the database layer of the architecture or a solution. And we have completely isolated or separated API that running on AWS Lambda function, which means our API layer is fully serverless, including its associated database. Because as you can see in this slide, we use Amazon DynamoDB as a database layer for the all API operations. Once again, which means once we invoke any of the API methods, it will perform create, read, update, or delete operation on DynamoDB tables. Also, our AWS ALB is public-facing thanks to Internet Gateway attached to relevant Amazon VPC, and we can access our web application backends through associated domain name over Internet. And also, we expose AWS Lambda function, and we can also invoke our API methods over Internet as well. All right, the main question of this session: how can we make this architecture more secure and resilient, especially against OWASP top 10 threats? To answer this question, from now on, we will review and deep dive some of the AWS services, and the first AWS service we will review is Amazon API Gateway. But first, let's go back to our core architecture for a second. As I said, this architecture works fine with no issue, but there are some challenges of this current design. And basically, we have two main challenges. The first challenge is I need to use two different domains, more specifically two different subdomains, to access the same application. Another challenge is I need to handle authentication and authorization at two different places for the same application. Once on the EC2 instances for the web layer, and the second on AWS Lambda function for the RESTful API layer. Well, for the first challenge, you may suggest that use AWS ACM, AWS Certificate Manager Service, to request public TLS certificate, then verify domain ownership using DNS or email validation. Afterwards, associate this public TLS certificate with both AWS ALB and AWS Lambda function. Yes, you are right, this method works, but also comes with another challenge that we need to solve. And this challenge is, as long as we use the same domain to access this web application and the API, we also route incoming HTTP traffic based on the between EC2 instance workload and the AWS Lambda function workloads. That's why we can simply use Amazon API Gateway for both centralized authentication and the authorization system, as well as the route incoming HTTP traffic based on the URIs. However, to implement Amazon API Gateway into our current solution, we need to do some architectural changes, or let's say improvements, like seen in this slide. This is slightly the same architecture with the previous one, but we have three main differences. The first difference is I just changed the API part from monolithic to microservices, which means from now on, each and every AWS Lambda function represent one individual microservices, or let's say represent one individual API method. The second change or difference is, since we have Amazon API Gateway anymore, our AWS ALB and AWS Lambda functions are not public-facing, but private. And the third and last difference is, since we don't need Internet Gateway anymore, but we have VPC endpoint, more specifically interface type VPC endpoint, to integrate private AWS ALB and Amazon API Gateway service. After doing all of these architectural changes, we successfully implement Amazon API Gateway, and now we can focus on the security features and the functionalities of Amazon API Gateway. All right, let's begin with the most critical aspects of any application security, which are authentication and authorization. Amazon API Gateway offers multiple options for authentication and authorization. It integrates with AWS Identity and Access Management Service, or AWS IAM. This integration allows us to control accesses by using either IAM policies or IAM roles. And this is pretty useful feature, especially if you want to enforce resource-based access control for your web-based workloads running on AWS Cloud. It is also capable to integrate with Amazon Cognito, along with Amazon Cognito user pools. which means we can easily handle secure sign-up, sign-in, or the access control mechanisms within same system. Amazon Cognito handles all of these tasks on behalf of us. And Lambda authorizers. If you need custom authentications, you can use Lambda authorizers by integrating with Amazon API Gateway. For example, if you need verify users through third-party system or a custom logic, you can do it with Lambda authorizers with literally very, very few lines of code. Amazon API Gateway also supports transport layer security, which means all communications between our end users and the Amazon API Gateway can be encrypted in transit thanks to TLS certificates. It also allows us to issue our API keys, and with this feature, we can ensure that only authorized users or systems are allowed to interact with our web application backends, or only authorized users or systems are allowed to invoke our API methods. Throttling and quotas. API Gateway has also a rate limiting feature, and this feature allows us to set how many requests a client can make within a specific time frame. Also, with usage quotas, we can also define or set a number of total requests a client can make over a day, over a week, or even over a month. When it comes to encryption for highly sensitive environments, Amazon API Gateway integrates with Amazon VPC thanks to AWS Private Link Service. This integration is slightly more different than the others. That's why I will not dig deeper into this. But only thing that you need to know about this integration allow us to, or thanks to this integration, we can ensure that traffic stays within AWS network and never passing through or exposed to public internet. And of course, it is also capable to integrate with Amazon Key Management Service, AWS Key Management Service or AWS KMS, and this integration allows us to encrypt sensitive data in transit with managed keys, either AWS managed or customer managed keys. Amazon API Gateway also allow us to set up cross-origin resource sharing policies for our web-based workload. And with coarse policies, we can set or determine which domains or which subdomains are allowed to interact with our web-based workloads. Apart from all of these security features and the functionalities, Amazon API Gateway has also IP whitelisting feature that works at layer 3 networking layer, which means we can easily whitelist our trusted IPs or blacklist untrusted ones. Another question, how can we protect this solution, this architecture, against layer 7 application layer attacks? The answer is nothing but with Web Application Firewall or AWS WAF. With AWS WAF, we can write our own rules to control what kind of traffic we want to allow, what kind of traffic we want to block, or even what kind of traffic we want to monitor. And this could be based on anything from IP addresses to specific HTTP headers, URIs, or even query parameters. But we don't always want to create every rule from scratch, right? That's why AWS WAF also offers AWS managed rule set, which are predefined by AWS to prevent common web-based attacks such as SQL injections, cross-site scripting, file path traversal, insecure deserialization, server-side template injections, and so on. AWS WAF has also bot control feature, and with this feature, we can easily detect and block unwanted and malicious bot traffics while allowing good bots such as search engine crawlers. This feature helps us to reduce unwanted traffic without affecting the legitimate user's experience. It is also capable to control traffic volume via IP rate limiting and the throttling mechanism. This feature is specifically super useful for such a scenarios where implementing CAPTCHA or reCAPTCHA mechanisms are not possible, such as RESTful API like in our case. Geo-restrictions. With AWS Web Application Firewall, we can restrict accesses based on the geolocations thanks to geo-restriction feature. For example, if your business operates only in North America, then you can restrict traffic which coming from the outside of the region or a country thanks to geo-restriction feature. This feature help us to tighten the attack surface of the application as well as reduce the number of possible attack vectors against our web applications. When it comes to logging and monitoring, AWS WAF logs each and every request that is processed. And these logs can be sent to Amazon S3 for the storage purposes, or you can send these logs to Amazon Kinesis for near real-time data processing or near real-time threat detection, or you can send these logs to Amazon CloudWatch to feed your event-driven architectures. Also with Amazon CloudWatch metrics, we can monitor key metrics such as how many requests allowed by AWS WAF or how many requests blocked by AWS WAF. Also allow us to set up alerts based on the unusual traffic patterns or network anomalies. But if you need to implement more complex logic for your web-based workloads running on AWS Cloud, it is not a problem because as you can see in this slide, AWS WAF is super capable to integrate with other AWS services. Whether you are using Amazon CloudFront to distribute your content distribute your static contents globally, or application load balancer to distribute traffic to your backend workloads, AWS WAF just sits in front and performs security filtering at layer 7 application layer. All right, another question. How can we protect this solution, this architecture, against layer 3 networking layer as well as layer 4 transportation layer attacks? With AWS Shield. AWS Shield is a managed DDoS service that comes with two options, Shield Standard and Shield Advanced. While Shield Standard is automatically included at no extra cost and provide basic DDoS protection, today we will focus on AWS Shield Advanced, which provides more comprehensive DDoS protection, real-time insights, and incident response support. AWS Shield Advanced is capable to work at layer 3 networking layer as well as layer 4 transportation layer. And network layer DDoS protection prevents DDoS attacks such as IP spoofing, and transportation layer DDoS protection prevents DDoS attacks such as TCP and UDP float, SYN float, or Smurf attacks. It is also capable to work at layer 7 application layer, and application layer DDoS protection prevents DDoS attacks such as HTTP float or desync attacks. Real-time insights. With AWS Shield Advanced, we get real-time insights via its global threat environment dashboard. This dashboard allows us to monitor all active DDoS attacks across all AWS regions and on all AWS services, giving us a clear view of global threat trends. Beyond DDoS protection, AWS Shield Advanced integrates seamlessly with AWS Web Application Firewall for web application security as well. With AWS Shield Advanced, we get 7/24 access to AWS DDoS response team. This team provides hands-on assistance during DDoS attacks. They help us to analyze the attacks and make mitigation strategies. And the last feature of the AWS Shield Advance, which is DDoS cost protection. For example, during a DDoS attack, if your servers scales to handle unexpected traffic due to a DDoS attack, then thanks to DDoS cost protection, AWS will not financially penalize you because of this scaling activity. So what does this mean in real life? All right, it means that AWS will review and evaluate a DDoS attack, or let's say the scaling activity, and if they decide the root cause of the scaling is a DDoS attack, then thanks to DDoS cost protection, AWS will not charge you any money because of this scaling. All right, so far we have talked about Amazon API Gateway for some proactive security controls, also discussed about AWS Web Application Firewall, which provides security filtering at layer 7 application layer. Also mentioned about AWS Shield, or more specifically AWS Shield Advance, to protect our web-based workloads against distributed denial of service attacks at layer 3 networking layer, layer 4 transportation layer, as well as layer 7 application layer. So what about DNS-based attacks? How can we protect this solution against DNS-based attack vectors? The answer is with Amazon Route 53. To mitigate DNS-based attacks such as DNS spoofing or cache poisoning, Amazon Route 53 supports Domain Name System Security Extension, or DNSSEC. DNSSEC adds an additional cryptographic layer onto DNS records and ensures that DNS responses are authentic and have not been tampered data in transit, thanks to key signing key and zone signing key. Anycase stripping. Anycase stripping allows each DNS request to be served by the most optimal edge locations, dispersing the network load and reducing the DNS latency, which automatically increase the resilience of the applications against DNS-based distributed denial of service attacks. Route 53 resolver endpoints. Resolver endpoints allow you to forward Route 53 DNS traffic between your on-premises infrastructure and on your Amazon VPC without having to deploy additional DNS server. And we have two types of resolver endpoints, inbound and outbound. Inbound resolver endpoints allow DNS queries and the name resolution to your Amazon VPC from your on-premises network or another Amazon VPC. In similar way, outbound resolver endpoints allow DNS queries and the name resolution from your Amazon VPC to your on-premises network or another Amazon VPC. And by using these resolver endpoints, we can ensure that Route 53 DNS traffic between AWS Cloud and on your on-premises network is secured all the time. Shuffle sharding for fault isolation. If any DNS server, or let's say any DNS worker node, fails somehow, the other DNS worker node on Amazon Route 53 notation we call as a DNS shard, the other DNS shard can be absorbed the remaining workload. So let's say one of our DNS shard hit by a DDoS attack or experience misconfiguration. In a typical shared environment, this situation could affect many customers, right? But thanks to shuffle sharding, only the users which connected to specific shard is affected. The rest of the users with their own unique shard configurations remain unaffected. It's a little bit complicated algorithm under the hood, but only thing that you need to know about shuffle sharding is it allows us to fault isolation, more specifically DNS-based fault isolations during traffic spikes or distributed denial of service attacks. Geo-proximity routing policies. Imagine that we are running globally distributed application across multiple regions and in multi-AZ setups, right? This feature allows us to manage and restrict Route 53 DNS traffic to our resources based on the geolocations thanks to geoproximity routing policies. To be honest, this feature does not affect the security directly, but it helps to increase the resilience of the application which globally distributed. Amazon Route 53, of course, integrates with AWS Shield seamlessly to fan out DNS traffic to many endpoints or many edge locations in case of distributed denial of service attacks. What about safer content delivery and securing our static contents? How can we handle these two topics in AWS? We can use Amazon CloudFront service to handle secure static content delivery. Well, every time when I ask what is Amazon CloudFront, more or less I always got the same response, which is Amazon CloudFront is a content delivery network of AWS Cloud. Yes, I can say that the answer is partially correct, but I can also say that Amazon CloudFront is literally much more than content delivery network. Geo-restrictions. When we talk about Amazon Route 53 a little while ago, we said that we can manage and restrict DNS-based Route 53 traffic to our resources based on the geolocations, right? Thanks to geoproximity routing policies. Now with Amazon CloudFront, we are able to restrict any kind of traffic, not DNS-based ones, to our resources for both static contents such as CSS files, JavaScript, images, and everything, as well as for dynamic contents such as server-generated response or API response. I mean, with Route 53, we were only able to manage and restrict DNS-based traffics. Now with Amazon CloudFront, we are able to restrict any kind of traffics, both static and the dynamic contents as well. Amazon CloudFront supports HTTP over TLS or HTTPS, and this means we can all communication between Amazon CloudFront edge locations and our end users can be encrypted in transit thanks to TLS certificate. Field level encryption. Field level encryption allows us to encrypt sensitive data field in the HTTP post request before they reach out to our backend servers. This feature, field level encryption, generally used by payment gateways or in banking industry in order to encrypt credit card or other PII informations rather than the encrypting the entire HTTP request body. With Amazon CloudFront, we can restrict access to S3 bucket objects thanks to origin access control feature. Origin access control prevents unauthorized accesses by bypassing Amazon CloudFront and accessing S3 bucket objects directly. In similar way with Amazon CloudFront, we can also restrict access to our static contents thanks to sign URL and sign cookies. These two methods, sign URL and sign cookies, give us a control over who can access our static contents and for how long. We can specify expiration times, we can restrict access to certain IP ranges, or even we can restrict access to specific AWS credentials. Origin Shield. Origin Shield, which acts as an additional caching layer between Amazon CloudFront edge locations and our origin servers. It helps us to reduce the network load on our origin servers during traffic spikes or distributed denial of service attacks. All right, another question. How can we handle secure authentication and authorization? Actually, when we were talking about Amazon API Gateway, we partially mentioned about these two topics, authentication and authorization. But in AWS, we have dedicated service to handle secure authentication and authorization, and this service is Amazon Cognito. With Amazon Cognito, we can easily set up secure sign-in, secure sign-up, and the access control mechanisms for our web applications, backends, mobile applications, or APIs. And it supports various kind of authentication mechanisms, including multi-factor authentications, password policies, and even federated accesses from third-party identity providers such as OpenID Connect, OAuth 2.0, and SAML. When it comes to logging and monitoring, with AWS CloudTrail, we can capture Amazon Cognito API calls. Then either you can use these API call logs to, or you can send these API call logs to your third-party SIEM product, or you can send these logs to Amazon S3 to perform your own security analysis by running SQL queries thanks to Amazon Athena. Also with Amazon CloudWatch metrics, we can monitor, report, and take automated actions in case of events in near real time. And lastly, with Amazon CloudWatch Log Insights, we can configure AWS CloudTrail to send events to Amazon CloudWatch for monitoring Amazon Cognito AWS CloudTrail log files. I know it's a bit complicated, that's why I will reply once again. I will say once again, with Amazon CloudWatch Log Insights, we can configure AWS CloudTrail to send events to Amazon CloudWatch log files for monitoring Amazon Cognito CloudTrail log files. Now let's take a look at the sign-in example with Amazon Cognito, how it works under the hood. In the first step, a client provides credentials to Amazon Cognito. In the second step, Amazon Cognito, along with Amazon Cognito user pool, tries to validate user-supplied credentials, right? If Amazon Cognito validates user-supplied credentials, it returns temporary security token or ID token to the client. In the first step, client make an API call over HTTPS with this token. In the next step, when this API call hit to Amazon API Gateway, Amazon API Gateway communicates with Amazon Cognito in order to validate this ID token or temporary security token. In the fifth and last step, if Amazon Cognito verify this ID token, it redirects users to default page or the landing page and assign valid session cookies or JSON Web Token. It really depends on what kind of session mechanism in place. Let's say if it's mobile application, it will redirect users to default page and assign JSON Web Token, which is more common to use in the mobile application. Or let's say if it's web application, it will redirect users to default post login page and assign valid session cookie if the web application use cookies to manage user identities. What about our security sensitives and secrets? How can we handle secrets management in AWS? Today, we will use and implement AWS Secrets Manager servers to handle handling our security sensitives and the secrets, but actually we have one more option in AWS to handle secrets management in a secure manner, and this service is AWS SSM Parameter Store. But since AWS Secrets Manager offers more comprehensive security features and the functionalities compared to AWS SSM Parameter Store, today we will only focus on the AWS Secrets Manager. Okay, let's assume that we have AWS Lambda function that is responsible for authentication, right? Okay, let's say /API/authenticate API endpoint. For this purpose, this API method needs to validate user-supplied credentials by connecting to credentials tables in Amazon DynamoDB. But the point is, we don't want to store our Amazon DynamoDB credentials into AWS Lambda function as hard-coded or plain text. Yes, we can set Amazon DynamoDB credentials as an environment variable of the AWS Lambda function. We can do it, AWS offer this, but this approach will not solve our problems fully because this approach does not provide enough security for all possible attack vectors for security sensitives and secrets. That's why at this point we can simply use AWS Secrets Manager to solve this challenge. But also, as you can see in this slide, we also need to attach execution roles onto AWS Lambda functions to retrieve secrets from AWS Secrets Manager. Now, let's take a look at the content of the execution role. Then afterwards, we can deep dive the security features of the AWS Secrets Manager. When you attach execution role to AWS Lambda functions, more or less it will look like this. It's similar to IAM policies or IAM roles. But the question is, how should we read this execution role, right? Now, let's try to read this execution role together. This execution role allows relevant actions on this resource. Once again, this execution role retrieve the secrets in US East 1 region under associated account ID. And the name of the secret we want to retrieve is uppercase secrets underscore name. Encryptions of secrets. Before they are saved, all secrets stored in AWS Secrets Manager are automatically encrypted at rest using AWS Key Management Service or AWS KMS. This means even if someone gains unauthorized access to our secrets stored in AWS Secrets Manager, they wouldn't be able to read it without proper decryption keys. Automated secret rotations. AWS Secrets Manager takes care of secret rotation for us. It rotates secrets automatically without causing any downtimes or service interruptions, which is super helpful for site reliability engineers or, let's say, in general, platform engineers. Tracking secret accesses. AWS Secrets Manager integrates seamlessly with AWS CloudTrail, or in other words, with AWS CloudTrail, we can capture AWS Secrets Manager's API calls. Or this means that we can easily track each and every interactions with our secrets thanks to AWS CloudTrail. Who accessed or modified a secret, what secret was accessed, when it happened, and from where. All these informations can be tracked thanks to AWS CloudTrail. This is going to be the last question from my side. Can we fit everything on one slide? Well, if we try to fit everything on one slide, our final architecture will look like this. And now let's take a look at our final architecture. As we spoke before, we use AWS Lambda functions to build our RESTful APIs, which means our RESTful API layer is fully serverless. Also, we store our data in Amazon DynamoDB, which is also serverless, and we don't worry about the infrastructure maintenance, operating system updates, scaling, or provisioning capacity. We also use and implement Amazon API Gateway that also scales automatically and route incoming traffic based on the routing policies. We use AWS Web Application Firewall, provides protection or prevents common web-based attacks at layer 7 application layer. Also, we implement AWS Shield, more specifically AWS Shield Advanced, which provides DDoS protection at layer 3 networking layer, layer 4 transportation layer, as well as layer 7 application layer. And we also use Amazon CloudFront to distribute our static contents globally. Also, we use Amazon Route 53 for DNSSEC, NICS stripping, and the shuffle sharding, and as well as the geo-proximity routing policies. And lastly, we use Amazon Cognito for secure authentication and authorization. And sorry, for the last one was the AWS Secrets Manager to handle secrets management for our case. Yes, my session ends here. I know I exceed my time, but since we don't have any other session after this one, I think it wouldn't lead any problem. Thank you everyone for coming here. Thank you for joining. Any question? If there is no question, I mean, it might be two things. Either I did very well or all right. Thank you, everyone.
There's a lot that I didn't know, so I'm going to look into it. Do you have a blog by any chance?
I don't have a blog. I mean, but I have. I generally share my analysis on my GitHub profile as a repository. But they are more into the application security because I am working. I mean, on the cloud security side, I am working as a cloud security architect, which means that I am more into let's say, or I am more close with the blue teams. But on the application security, I am completely the bad guy on the.
Yeah, of course. Of course. So it'd be most of the stuff on the GitHub would be more geared towards application security.
Yes, yeah. I mean, definitely application security. Some of them are the vulnerabilities that I found. Some of them was the reproducing of the new vulnerabilities, let's say, or end-day vulnerabilities we just discovered and not reported yet, or some of them I just directly going through the patch analysis and let's say the kind of reversing and so on.
Got it.
But for the AWS security, I mean there are many blogs, but I mean I think it will be better for you to follow the AWS own official site because there are a lot of
like a certification program?
No, it's a training program. There are plenty training programs that you can sharpen your skill. But are you more into the offensive security or the defensive security in general? Because you can, if you are into the offensive security, you can also deal with red teaming in the AWS infrastructure as well. Yeah, but you need to know a lot of things. But of course, you can do it. But in general, utilizing AWS services to build some things sounds more fun for me.
Yeah. Okay.
Yeah.
Well, thank you so much. I hope you continue giving your talk. It was very informative. Okay.
Thanks, man. Thank you.
I'm going to add you on LinkedIn too. Okay.
All right. I'm waiting.
Thank you so much.
See you. Have a good time.
I just want to say it was a great presentation.
Yeah. Thank you. Thank you. Nice to meet you.